Hello, and welcome to 5 Minute Math. My name is Aaron Daffer, and today we are looking at Algebra 1 Star 2025. If you would like to follow along, I've created a custom statewide item analysis report. You could access it by using the tiny URL or the QR code on the screen. I'm going to be going through each item individually, but if you ever want to jump ahead, you can use the timestamps on the screen, or you can use the bookmarks that are available at the bottom of the video. For number one, we are rewriting polynomials. This is A.10d, and we have an expression that we simply need to rewrite. We're going to use the distributive property twice. We're going to take this 1.5, we're going to multiply it by the 4j and the negative 10k, and then we're going to do the same thing with that 2.5, multiply it by both terms. We do need to keep in mind that we've got that negative there. So really, we're going to think of it as a negative 2.5 multiplied by the 8j and the 8 and the 6k. So let's just rewrite this. Let's make it 1.5 times 4j minus, and then I'll put that 1.5, 10k, and I just got that minus there just to kind of keep that. Then what I'm going to do is I'm just going to make both of these minus because it's minus 2.5 8j, and then it's that minus 2.5 in the 6k, minus 2.5, 6k. All right, lots of decimals, so let's get rid of those. So 1.5 times 4, right, that's going to be 6j minus, and then I've got 15k minus, that is 20j, and then that is going to be 15k. So let's combine like terms. So right, I've got 6j minus 20j, and then I've got negative 15k, negative 15k. All right, so that's easy. That's going to be negative 30k. 6 minus 20j is going to be negative 14j. So negative 14j minus 30k. And so our answer here is C. And for our opening problem, it wasn't too difficult for students. We had 61% of our students get this correct. And there wasn't really a distractor that stood out as being too difficult. That's a lot of work. You either get it or you're guessing. And so the trick here is obviously not just the distributive property, but keeping up with that negative right there and making sure that these two terms over here also become negative. Next, we are looking at graphing exponential functions. This is A.9d. And we have a graph of an exponential function already shown to us, and we simply need to evaluate these statements. All right, so let's look at these statements. So the equation has an asymptote of x equals 4. All right, so if x equals 4, that means what we have is we have a vertical line. The y is infinite. The x is always 4. And an asymptote means it is increasingly going to approach that 4 but never touch it. Well, that doesn't work because it actually goes across it. On these basic exponential functions, your asymptote is always going to be x equals 0. Now, as you get into Algebra 2, we can start shifting this up and down, and the asymptote starts changing. But just for your basic function, right, that follows this y equals a times b to the x, your uh, your asymptote is going to be y equals 0, not x equals 0. So b, the function is increasing at the interval x and decreasing at the interval. Okay, so increasing means going up. So as x is greater than 0, it means it's increasing, and decreasing at x is less than 0. That is exactly the opposite of what is happening. So if we were to change this, then that would be correct. But no, we're not there. All right. The x-intercept, well, there is no x-intercept, so we can already say that's incorrect because the asymptote is going to be this y equals 0 right here. So there is no x-intercept, but there is a y-intercept, and it very clearly crosses right there at 3. So our y-intercept is 0, 3, which means that is our starting position. If we were to write this in equation form, right, that would be the A term, 3. That's what gets you the y-intercept. So we had 79% of our students get this. This was pretty good. Uh, Not even the easiest item on the test, though. This, as a 79%, this was our third easiest item on the test, which means there are two that are even easier than that. But this was, I mean, when you're getting close to 80%, you should be really, really glad and really happy with how the students did. For number 3, we are simplifying square roots. So this is A.11a, and this is definitely going to be on the easier side. We just need to find an expression that's equivalent to square root of 50. What we need to think of that is almost think as if you're factoring that 50, right? And 50 can be broken up into 25 and 2. It can also be 5 and 10, but 5 and 10 doesn't do anything for me. You're looking to see if you can get a perfect square coming out of that. So 25 times 2 makes 50, so square root of 25 times the square root of 2 makes square root of 50, but square root of 25 is 5. And so that's it. That's our answer. And that was even easier than the last one. That was our second easiest. We had 81% of our students get that. And that most students could probably do that without working it out. They can visually probably manipulate that mentally, because that's a very quick pulling out that 25, taking the square root. And so that definitely was not a challenge for our students. And this is typically how the STAAR test goes. It starts off easy, gets hard in the middle, ends off on the easier side. For number 4, we are looking at writing systems of equations. This is A.2i, and we need to write a system of linear equations for these two lines. Now, there's two ways we can do it. Right? One way is we could find our intersection. So we do have an intersection here, and it is at the point 3, 5. What we could do is we could plug those coordinates into each of these equations for A, B, C, and D and find the one that works for both, because the 3, 5 should be a solution for both. But we're not going to do it that way, but though that is valid, it doesn't work every time because sometimes they don't give you the equations to check out. Sometimes they just give you the graph and you have to generate the equations from the graph. So we'll do it that way. So we need to write two different equations. You'll notice that A and B are listed in slope-intercept form, and then C and D are listed in standard form. So I'm going to write them in slope-intercept form, and if we don't find them, we'll need to convert them over to standard form. So we've got that one point. All we need is a second point, because remember that our slope is change in y over change in x. And we could calculate it like this, or we can just do the rise over run. Okay, and so let's see if we can find another point on this first line. Look, it looks like it's just going down. Look at that. Just one at a time. So if we start at this one, right, it's going to be up 1 over 1, up 1 over 1, up 1 over 1. So that looks like that has an m of 1, right? Because my other point here, let's take this point right here. Let's say this is 2, 4. So that's going to be 5 minus 4 over 3 minus 2. That's 1 over 1. So my m of 1. Now, that's partly there. I need the b. I need the y-intercept. Well, the y-intercept is clearly visible right there, so it's going to be 2. So I can say y equals mx. My m is 1, so I don't really need to write that. X plus 2. Well, that's the easy one, apparently. What we need to do is we need to find the hard one. The hard one is going to be this other one, and that's going to be the difference. So let's find another point. And it looks like it goes through a point right there. Looks like it goes through a point right here. Now this is going to be a negative slope. It goes down 1, 2, 3, 4, and then over 1. 1, 2, 3, 4 over 1. And then my point here is 4, 1. So if we want to calculate it, we can say m equals, we'll say 5 minus 1 over 3 minus 4. So that's going to be 4 over -1, so -4. All right, so I have a slope of -4, and the y-intercept is not visible. It's going to be positive, right? It's going to be like, it's going to go up past maybe 12, 14, 15, or something like that. So either one of these look like they could work. So I need to actually calculate it out. So let's just take a point. Let's take my 4, 1, and I'm going to plug those in. So my y is 1, my m is -4, my x is +4. I'm just going to solve for b. So 1 equals -16 plus b. Add the 16. There we go. B equals 17. So y equals -4x plus 17. And we've got that right there. So we didn't need to mess with the standard form because our answer there is A. And that one was also on the easier side. We had 66% of our students get this one correct. It's 17.9. We had 7% of our students get that D down there. So that one, those two really weren't chosen that much. And I could definitely see here, right? You get that y equals x plus 2. That's pretty easy. Look at the difference between A and B is simply that y-intercept, and rather than calculating it, they might have just guesstimated it. And so rather than doing the calculation, those are really close. They got close, but they did not get the correct answer. So this was tied for our 8th easiest item on the test. Next, we are looking at quadratic domain and range. This is A.6a. And there are a few different ways that we could solve this. So one option would be to graph everything. And you just plug everything into Desmos or into the TI-84 that is provided for you. And what you're looking for is you're looking for a range of all real numbers greater than or equal to 1. All right, so y needs to be greater than or equal to -1, which means this needs to be our minimum, right? So we're looking for a graph that is going to kind of look like this. Well, and it might be off left or right. It doesn't really matter. We're just looking for the range. And so we want a minimum of -1. That's what we're looking for. So you could throw everything into one of the two calculators provided for you, and you can find the one that looks like that. That would work. Option 2 is one I'm going to show you, and that's how we can evaluate the equations. Now, there is a form that we are familiar with in Algebra 1, and that is called the vertex form. So you see that on, I'll put it right at the very bottom. F of x equals a times the quantity x minus h squared plus k. And that actually helps us. And so let's take a look at that. So f of x equals a x minus h squared plus k. That's called the vertex form, and we can actually use that to solve this problem. So what this gives us is if we can get quadratic equation to look like this, sometimes we have an a, sometimes we don't. But we need the x minus h quantity squared, or we need the k. This actually gets you your vertex, right? Your vertex of h and k. So we already have two of our answers that are like this, so we can evaluate this, okay? All I'm looking for is the k, which is the y value, right? I need it to be -1, so I don't have it here. I've got a vertex right here of, remember, needs to be x minus -3 squared plus 1. That's how we get that plus 3 right there. So that means my vertex is going to be -3, which is fine, but it's +1. And it's positive right here. There's no negative right there, which means it's opening up, which means this one is going to be something kind of like this. And I've got a 1 as my minimum, and it opens up. So that's not it. We'll do this one. And let's rewrite this so we see that negative. X minus negative 4 squared minus 17. Okay, so that's where we get that plus 4. So that means my vertex is going to be negative 4, negative 17. Wow, that's going to be way down here, something like this. Let's pretend we got that right there, and that's negative 17. And there's nothing right there, which means it's positive, which means it's opening up. Okay, so it's not either of these. Now, A and B are not in that form, but I can go ahead and eliminate A because it's got a negative. Now, I see that negative 1, and I'm excited about that negative 1, but since it's negative, it's actually going to be opening down, right? So it's got that negative coefficient. It's going to be opening down. I want it to be opening up. So it's got all real numbers greater than or equal to 1. So there's only one left. It's B. Now, how do we get that into our vertex form? Well, we can complete the square. So if you're not as familiar with that, what we do is we want to get this. We're going to set this equal to 0, right? And we're going to do a series of moves. X squared plus 4 plus 3 equals 0. First, let's get this 3 over here. So it's going to be x squared plus 4x. We're going to leave that blank, right? What we want to do is we want to take this b term, and let me change colors here because this is the tricky part. Take this b term, and you want to take half of the b term and then square it. So half of the b term is 2, and then if you square it, that's back up to 4. That's fine. So we're going to add that 4, but we can't just add 4 there. We have to add 4 to both sides, right, to keep a balanced equation. So then what we're going to end up with, and I'm going to move it over here so we can still see it, is we have a perfect square. Take a look at what we've got here. Look at our reference material, what we just created with a perfect squared trinomial. So now we can get it into that vertex form, right? So we can say this is going to be x plus half of b, right, squared, which is 2. So I just shrank this into that. And then I need to simplify this. Negative 3 plus 4 equals 1. I need this 1 to be on the other side. So I'm going to do that. That gets rid of it. And now I've got f of x equals x plus 2 squared minus 1. Now I'm in my vertex form. And so we can rewrite it like this. X minus negative 2 squared minus 1. So my vertex is going to be negative 2, negative 1. I don't care about that negative 2, but I do care about that negative 1. And it is going to open up because there's nothing right there. So our answer is B. Now that was kind of the long way. If you want to use the graph, it's probably the easier way to do it. How did we do on this? This one was definitely harder. We only had 42% of our students get this right. We had 33% of our students get that right. They saw that negative 1, and they knew that was going to affect the y-intercept, the maximum or minimum. What they didn't take into account was that negative coefficient. We had 15% here, we had 9% here. So this definitely was a lot more work. This was actually tied for our 11th most difficult item on the test. And so I would definitely work with students here, show them multiple options, complete the square, put everything into the calculator, show them that they can solve this with multiple methods and not just one. We don't want them to tie just to one algorithm because then that's going to make them think that they might not have options, and they always do in algebra. That's the fun thing about algebra. Next, number 6, we are looking at 8.2c. We are writing linear equations, and we have a table of values. We need to write it in slope-intercept form. So that's going to be y equals mx plus b, right? And we have the m and the b missing. Our f of x is sitting as our dependent variable as our y. So we need to find two different values, the m and the b, and we can use our reference materials. Then if we look at the very bottom, we will see these linear equations, and we'll see slope of a line, change in y over change in x. That's what that m is. And so that's what we're going to do, change in y over change in x. Now let's just pick a y2 and a y1, x2 and x1. I can use any x's and y's as long as the y2 is matched up with the x2 and the y1 is matched up with the x1. I pick those simply because they're positive. And when you subtract negatives, there's more of a chance of getting things incorrect. So 14 minus 5, that's my y sub 2 minus my y sub 1. And then 10 minus 4 is my denominator. That's my x sub 2 minus my x sub 1. So that's going to be 9 over 6, which makes 3 halves. You can also see it right here if you just look at the change, right? From negative 10 to negative 4 is a positive 6. From negative 6 to negative 4 is a positive 4. So that ends up being 6. Change of 6 over change of 4. Right, so you could do it either way. So 3 halves, that's going to be our m. Now we need a b. And so we can pick any of these values. And so I'm just going to pick, I haven't used those two yet. Let's plug those in. And so our negative 4 is going to be our f of x. We're going to plug it into this equation down here. Negative 4 is our f of x. We just figured out that 3 halves is our m. Our x is negative 2. And then we simply need a plus b. B is the only variable, so I can solve for b. So those two are going to cancel out. That's going to be negative 1. So that's going to end up being negative 4 equals negative 3 plus b. Or you can just multiply that out. That's going to end up being negative 6 over 2, which becomes negative 3. Add 3 to both sides. You end up with negative 1 equals b. Now, we would normally write this as 3 half x minus 1. But since there is no minus 1, we can add a negative 1. That's a little bit of a misdirect there that might have thrown some students off. And that is going to be our answer. So this is a 2-point problem. And we have f of x equals 3 half x plus negative 1. Now, how did we do? Well, we had 51% of our students get both points. 20% of our students get half credit. So if you take that half credit and add it to full credit, you're going to get 61, and then 29% of our students were unable to get anything. So 61% is pretty good, but the fact that almost 30% of the students couldn't even get the slope, and this is just table of values here, it means we need a little bit more work here. And this was on the easier side of the test, tied for our 14th easiest item on the test. For number 7, we are calculating a correlation coefficient. We definitely need technology on this one. This is A.4a. All right, and we need to look at a few things here that are going to tell us what we're doing and why we're doing. It does tell us the correlation coefficient. And take a look at our answer selections. We are simply looking at our uh, association here. Strong positive, weak positive, strong negative, weak negative. So we need to interpret our correlation coefficient. So let's calculate it first. And there's a few different ways you can do this on either calculator. My preference is Desmos, but if you'd rather do something else, that is fine. And so what we're going to do is we're going to simply type in all of our values into a table. So we're going to create this table right here. And the one thing we want to keep up with is let's make sure that we are typing everything in correctly. So I'm just going to type in my x values first. So 8, 12, 17, 23. Come back and get my y values. And we don't need the comma, so just type in the raw numbers. And what we want to do is we're going to end up plotting these points. Now we don't need to look at the graph. It's going to be very, very skewed if you've got the y values all the way up there. But what we want to do is we want to graph all of these points and then ask with this equation, right? And we want to type this equation in. So y sub 1, we want to use this tilde right here. And we want to say mx sub 1 plus b. So it looks like it is our slope-intercept form, except we've got a few changes. So you have to make sure we type all of this in correctly. So instead of the equal sign, we have the tilde, and that is above the tab button, shift, and then the little um, accent mark above the tab right underneath the escape key. And you want to make sure instead of y equals mx plus b, it's y sub 1 tilde mx sub 1. So that y sub 1 and the x sub 1 are going to pull specifically from this table that we've already created. Now, there's only one thing we need from this. We don't need to look at it. What we do need to do is we need to go ahead and write down, and let me make sure I've got it here. It's this R. So we don't need the E, we don't need the B, we don't need the M, we don't need the R squared. We do need that R. So let's write this down. R equals negative 0.9907. That's all we need. Okay, once we have that, we're now ready to interpret this. So how do we interpret this? Well, an R value shows you how strongly correlated two sets of values are. So in this case, the number of months and a checking account balance and the remaining balance. And it's always going to be from -1 to 1. And I always draw it like this because you get 0 in the middle. So your R value is always going to be between -1 and 1. Okay, and if you get above 0.7, okay, this is going to be strong, and negative 0.7, this is also going to be strong. Anything in the middle between negative 0.7 and positive 0.7, this is going to be weak. And this is measuring the strength of the association. So you're weak here, and then you're strong if you're between negative 0.7 and -1, or positive 0.7 and positive 1. And then the only difference is this is a strong negative, and this is a strong positive. And this would be a weak positive and a weak negative. You get to 0, there's no association. So look at this. Every single month, as the months go up, right, these months are increasing. What's happening to our remaining balance? It's decreasing every single month. It never goes back up. It never stays flat, which means it's a negative correlation. As one goes up, the other goes down. And in this case, we've got the negative 0.9907, so that means it is a strong negative. So our answer here is C, because it's that negative 0.99. That gives us that strong negative. Now, that is a technology enhanced item. We need our calculator to figure that out. Some kids understood this, and the rest were basically guessing. And you can tell by the answer distribution. We had 48% of our students get the correct answer. So that's definitely on the harder side. But then look at what we have: 16, 17, 19. So this right here just means we either knew it or we were guessing. And so we need to spend some time on this. This is a supporting standard, so you're not going to necessarily see it every single year. But when you do see it, we need to know how to do this. And just think of this: y sub 1 mx sub 1 plus b. If we can think of that, it looks like the slope-intercept form, which is those few changes. We can get our kids to do this. Number 8, we are writing linear equations in various forms. This is a point 2b. And in this case, they're actually asking for this in slope-intercept form. And we have a line that passes through a certain point and has a slope of this. Okay, so what is our slope-intercept form? Y equals mx plus b. And they give us the slope. All right, so m equals negative 2 over 11. So y equals negative 2/11 x plus b. All we need to do is figure out what the b is, and we'll do it like we did a few problems back. We're going to take our point, we're going to plug those values in. Our 22 is our x, 5 is our y. So let's make this 5 equals negative 2/11, and that's times 22 plus b. We're simply going to solve for b. All right, so we're going to simplify this. That's going to end up being 5 equals negative 2 times 2 is negative 4 plus b. Add 4 to both sides. 9 is what b actually is. So we can rewrite this as y equals negative 2/11 x, and then that plus 9. And the challenge there is 9 doesn't show up as, either of the x or the y values or as a slope, so it kind of seems like it's a number that comes out of nowhere. So we have to know how to manipulate the equations to get it to work. All right, so we had 66% of our students able to solve this. It was pretty straightforward. So that definitely made this one of the easier problems. In fact, this was tied for our 8th easiest item on the test. Next, for number 9, we are looking at zeros of quadratic functions. This is A.7b, and it might seem like this is going to take a lot of work, but quite honestly, we've got everything we need right here. We don't really need any calculations. So we need to figure out first off, what is a zero? Well, a zero is a value that makes a function have this h of x, or our dependent variable, turn into 0. So what could I put into this x to turn this into 0? Well, we like to think of the zero product property, right? Because if you multiply anything by 0, everything else turns into 0. So if I can turn this into 0, or this into 0, you can't turn that 3 into 0. The 3 is just a 3, but either of these two binomials, if I can turn those into 0, then my h of x becomes 0, and then whatever value that x is, that is what we call a 0 because its output is a 0. So we like the zero product property. We take each of these binomials, we set it equal to 0, and we ask what would we do to make it 0? Well, you can probably do it mentally, but we can still use the addition property of equality or the subtraction property of equality to make those equal to 0. So x equals positive 5, x equals negative 7, and that makes sense. If we were to put a positive 5 right there, 5 minus 5 makes 0, everything is 0. Or negative 7 right there, negative 7 plus positive 7, 0, everything else turns into 0. So then my two zeros are 5 and negative 7. They are also known as solutions. They are also known as x-intercepts. So we need to get comfortable with 3 different ways that we can discuss the same idea: a 0, a solution, or an x-intercept. Now, we've got one answer here. They are 5 and negative 7 because h of 5, that means if I plug 5 into this equation right here as my x value, that becomes 0. Or h of negative 7, if I plug in my negative 7, becomes 0. So that gives us the explanation as well, which might have thrown a few students off. They might not know why a 0 is a 0, but it's because h of that number, or if you have the function of that number, your output is a 0. So our answer is C. And we did decent on that. 64% of our students got that correct. We had 18% of our students get this. And the reason we got 18% was actually kind of interesting, because think about these numbers. These numbers are simply taking that 3 and distributing that. Just 3 times negative 5, 3 times positive 7. And that's not how the zero product property works. We don't need that 3. That 3 is extraneous. It doesn't do us any good. But you can see where that misconception is. Students not sure what to do. They just distribute because that's huge in Algebra 1, and I get that. So this ends up being our 11th easiest item on the test. Next, on number 10, we are graphing inequalities. This is A.3D. We're going to have quite a bit of scrolling here. So I'm just going to write A, B, C, and D here, right? Because we're going to have to scroll. Now, we need to find the graph that best represents this. We could graph that, put that into our calculator. It would not take it into standard form, so we need to put that into slope-intercept form. But we could do that. We can also eliminate some of our answers. So let's take a look at this. We have a less than or equal to sign. That equal to means we're going to have a solid line. So A could possibly work, B could possibly work, but take a look at C and D. They both have dotted lines. Those are either greater than or less than. And so C is greater than because the shading is above the line. D is less than because it's below the line, but it's not greater than or equal to or less than or equal to. So we can get rid of those two immediately. So we only have two choices, and it looks like the graph is exactly the same. So we'll look at A, but we're graphed in this, the line is the exact same line on A and B. You've got zeros there, right? Because if you were to pretend this was an equal sign, and if you make a 0 of x, right, that would end up being minus 0. So you can say 3y equals negative 6. That goes away. Y equals negative 2. So when x is 0, y is negative 2. We do the same thing. 3 times 0 minus 2x equals negative 6. That goes away. So we divide by negative 2, and you get x equals positive 3. So when y is 0, x is 3. So that's where we get those 2 points from. Our question is, are we at shading above the line? Or are we shading below the line? Well, let's look at this in slope-intercept form. Okay, so we're going to take our 3y minus 2x less than or equal to negative 6. And we have to look at it in slope-intercept form because if we multiply or divide by a negative coefficient, we end up flipping the inequality. So I want to get that y isolated, so I'm going to add 2x to both sides. So I'm going to get 3y less than or equal to 2x minus 6. So I'm going to divide by 3, and so that's just going to end up being 2/3 x, and that's minus 6/3, which ends up being 2. But most importantly, what I'm looking for is, did I flip my inequality? I did not flip my inequality, and we could have figured that out if we wanted to just look at the coefficient for y. If the coefficient for y was negative, we would have flipped the inequality. In this case, we did not. Therefore, it's a less than, which means we're going to be shading below. Now, if we want to test this, what we could do is we can just plug in 0, 0, and see if that's going to be in the solution set, right? So 3 of 0 times 0 minus 2 times 0 less than negative 6. So 0 minus 0 is 0. So 0. Is 0 less than negative 6? No, 0 is actually greater than negative 6, because if you look at it on a number line, here's 0, here's negative 6, right? 0 is greater, which means 0 is not going to be in our solution set, which means B is our answer. We also could have gotten that by just looking at our less than or equal to sign, but wanted to show you multiple ways. So this was definitely quite a bit of work for our students, and we only had 49% of our students get the correct answer. So let me put that right here. Correct answer B, we had 49% of our students get that correct. We had 22% choose A. So that was at least the correct uh, dotted or dashed line. It was just shaded in the wrong area. 15 and 14 weren't even the correct. Those were the percents for C and D. Those weren't even the correct lines. Not only was the line graphed incorrectly, but it was a dashed line rather than a solid line. So this was definitely on the harder side. This ended up being our 20th most challenging item on the test. And so we need to walk our students through the thought process here of how to solve this, how we can eliminate answers by looking at the line, dashed or dotted, graphing if needed, if those were two different, these were the same lines, so we didn't really need to graph A or B. But, putting in zeros for X and Y, we could have graphed it if needed. And then just looking at that leading coefficient for the Y to see, is that going to be a negative? Because if so, then you're going to end up flipping your inequality. Number 11, we are looking at 8.5c. We've got systems of linear equations, and we need to find a solution. Now, there's a few different methods we can use. but it looks like they've got substitution lined up for us. And the reason I say that, right, we could do elimination, but one's in standard form and one's in slope-intercept form, so we'd have to move it over. Substitution is when you just basically substitute in one equation for a variable. And that works when you can either solve for x or solve for y. They've got this y set up right here. So I'm just going to plug that y into the first equation, and instead of the y, I'm going to write what y is equal to. I will need to distribute, but that's going to give me only x's. So 3x minus 5, and now I'm going to substitute in this right here. Negative 6x plus 2 equals 12. So I have to do a little bit of work, but I've only got x's, so I can solve for x. You can't solve when you've got two different variables in the same equation. So let's distribute this. Let's make sure we do that right. So 3x. All right, so negative 5 times negative 6x. That's going to be two negatives. That's going to end up being 30x. I've got a negative 5 times a positive 2. So the positive and negative makes a negative. 5 times 2 is 10 equals 12. So I've got 33x, and that's a minus 10. That's a 12. Let's add 10. Okay, so that's going to be 33x equals 22 divided by 33. You get x equals 22 over 33, but that simplifies to 2/3. And so we just need the value of x, and that is our answer. Now, if we want to verify, right, we could plug it back in there, but then we'd have to get a value of y, and then we'd have to make sure it works in both. So we really just need this first step in order to solve. Get our answer of C, 23, but if we were looking for the solution, we would need both the x and the y value, so I would then need to plug that x value into either of the equations and solve for y. And then for it to work, it needs to work for both equations. That's what a true solution does, is one x and y value that works and solves both equations. If it doesn't solve both, then we messed up somehow. So this was only 52% accurate by the students that took this last year. And we had 22% of our students choose B. So let's take a look at that, because that was kind of a interesting misconception there. And so it was distribution and it was the substitution there. And so students did this. We did 3x minus that 5. We did all this that we needed to do because it was set up for substitution. And then what ended up happening is we just lost the negative 5. And that just somehow disappeared for some students. They just thought they substituted in the y for both the 5 and the y, and the y still needs to be multiplied by 5, because what you end up getting is 3x minus 6x plus 2 equals 12. If you just ignore the negative 5, you get negative 3x, take that 2 over there, equals 10, so x equals negative 10/3. That's how we got there. So there are some students still struggling with substitution and realizing that that coefficient, that negative 5, needs to be multiplied by everything on the inside. And it doesn't just disappear when you substitute in that other equation for y. This was our 23rd most difficult item on the test. So kind of right in the middle of a 50-item test, slightly on the harder side. Number 12, we are looking at parent functions. This is A.7c. And we simply want to know what is the vertex if we transform this, okay? So we could graph something if we want to, and I'll show you how it works with the graph, but we can also figure it out without the graph. So there's two different ways that we can do this. So when we are looking at this function, there are changes that happen within the parentheses, right? And there are changes that happen outside of the parentheses. All right, and so what we need to think of is this f of x minus 8, right, squared. plus k. That's how we can think of our transformations. This k is a vertical shift. And then this h, it happens within before the x gets squared. This is a horizontal shift. Now this is just a rule that you need to memorize, but you will see this with quadratics, you will see this with absolute value functions, you will see this with radicals. This right here is something you'll see all the way through Algebra 2 and Calculus. If you're taking a function and you're transforming it, it's this x minus h within the parentheses and then the plus k. That signifies your horizontal or your vertical shift. And then eventually you get to an a term out here, right, which does your compression and your vertical stretching. So we have something that happens within the parentheses. All right, so we're looking at a horizontal shift. But in order for it to be x plus 8.7, it's going to end up being x minus negative 8.7 squared, right? Because we got the squared. In order for this to turn into a plus, so you have to flip that when it's a horizontal shift. It ends up having to be x minus negative 7, and then we simplify it to x plus 8.7, which means it's a horizontal shift to the left. Okay, so it's a horizontal shift to the left, which means your x value becomes negative 8.7. We didn't do the vertical shift because that would be a plus k on the outside of the parentheses. Now, if you don't believe me, and if you can't remember all of that, let's graph it, because graphing it also works. All right, so I want to first show both. Let's just show our parent function. All right, so we're going to do f of x equals x squared. All right, so there's your parent function. We're used to that. Now, what did they say our new thing was? It was going to be g of x equals f of x plus 8. Okay, so g of x equals f of x plus 8.7. Now, we're not seeing anything because, let's see if we get that in there. There we go. I put the wrong value in there. You notice that it's going to take this g of x and it's going to interpret it. So we had to have the parent function in there, right? If we were to erase this, it doesn't know what to do with that. So it could do that if you wanted to go ahead and square that. Uh, but it's only going to work if you then replace this with, y equals, and then x plus 8.7 squared, right? You can get the same thing there, but you have to do quite a bit of changes. So let's go ahead and go back to the way we had it. F of x equals, so here's our parent function. And then now let's go ahead and make this g of x. And then we're going to make this f of x, but we don't need to square it because it already knows to square it. F of x, there we go. So let's take this superscript off. It thinks it's waiting for something. There we go. So you'll see we went over negative 8.7 simply because we changed it on the inside. So that's just a graphical way to justify why I know that is a horizontal shift to the left. And our answer here is going to be D. So you can solve it if you memorize the rules, or you can always plug it in, but you need to make sure you plug in either y equals and then x plus 7 quantity squared, or plug in the f of x and then the g of x. Either one of those situations will help you out. So our answer here, like I said, is D. And we only had 41% of our students get this correct. So this was definitely on the more challenging side. We had 30% of our students choose A. Obviously, everything here is happening with 8.7. They knew something was happening. And if you don't really know what's happening, you think this positive 8.7 is going to be a vertical shift up because 8.7 is positive. So I get that, but if it's within these parentheses, it's going to be a horizontal shift. And this ended up being tied for our eighth most challenging item on the test. So this was definitely on the harder side. Next, number 13, we are looking at rate of change. And this is A.3b. Seems like it's pretty simple because there's not a lot of words. But this actually was one of the harder items in the test. So which value represents the rate of change of y with respect to x for this function? Now, if you don't know what this means, right, that's going to be a little bit strange. Like, what do you mean y with respect to x? Well, that's the type of, when we're looking at the rate of change, one clue would be thinking that's typically what we think of our m. Specifically, right, we think of our rate of change. We'll think of it as our k, y over x, right? Y with respect to x is really what this is talking to. But if we're thinking of m, all they want us to do is put this in a slope-intercept form and find the slope. But they kind of hid it inside this formal language that we might not be familiar with. So once you know that, oh, they're just looking for the slope, well, that's pretty easy. Let's go ahead and solve this for y. Get this in from standard form over to slope-intercept form. And so I'm going to subtract x from both sides. Right, so that's going to end up being 7y equals negative x minus 14. Divide everything by 7. So y equals negative 1/7 x, or negative x over 7, minus 14 over 7, or minus 2. So there's your slope. So you might have seen negative x over 7, but even then you had to turn that into negative 1/7. So now you see why this seemingly simple problem actually ended up being quite a challenge, because you had to interpret the words there to know what exactly they were looking for. We had 48% of our students choosing this, and we had 21% choosing 7, 21% choosing negative 7. They didn't know what was happening. They just saw the 7 and they figured that was close. And we had 10% of our students choosing this. This was actually tied for 17th hardest or most challenging item on the test. Next, for number 14, we are writing linear inequalities. And so we've got a word problem here, a verbal description, and we need to put this into an inequality. Sometimes these are straightforward, sometimes they're a little bit challenging. So let's see. A baker wants to order apples and blueberries. All right, so apples is X, and then Y is going to be blueberries. Okay, so let's keep that in there. Apples cost $2.50 per pound, and apples are going to be X. So that's 2.5 times the number of pounds I want. Blueberries cost $3 per pound. That's going to be 3 times, there's my Y, the number of pounds of blueberries. So I'm immediately going to just match those um, to the correct variables. And the baker does not want to spend more than $75. Okay, so I've got my constant of 75, I've got my coefficients of 2.5 and 3, and I've got them lined up with my x and my y. Now I need to find my operations and my inequality. So if I'm ordering apples and blueberries, what am I going to do with those two quantities? Well, I'm going to add them together. That's going to be my total cost. 2.5 times the number of apples I buy, pounds of apples, plus 3 times the number of pounds of blueberries I buy is going to equal my total cost. And what do I have as my limits for my cost? Does not want to spend more than 75 bucks. So does not want to spend more than, I need to interpret that as less than 75 bucks. But can I spend 75 bucks? Actually, yes, I can. So does not want to spend more than 75. So 75 is fine, which means I need to make that less than or equal to. And so through that reasoning, I'm able to get this 2.5x plus 3y is less than or equal to 75. And we see our answer there as B. And we're simply writing that inequality and we are representing it algebraically. We only had 59% of our students get this correct. Not quite that 60% we were looking for. You see 21% chose D. Everything all lined up correctly, and they had the wrong sign. So we had these numbers are just made up. It's just 3 plus 2.5, but that's not how it works. These numbers were with the wrong variables, so that's why those were a little bit lower. But this ended up being on the easier side. This was tied for our 19th easiest item on the test. For number 15, we are looking at attributes of quadratic function graphs. This is A.7a. This is a hotspot, so we simply need to touch the part of the graph that we think best represents the y-intercept of function. And if you know what a y-intercept is, this problem should take you about 2 seconds. The y-intercept is where the graph of whether it be an exponential function, a linear function, or a quadratic function, where it crosses the y-axis, where x equals 0. So right here is where we need to cross. That's it. Our y-intercept is that uh, location that has a coordinate of 0, -3. And so to answer this, all we do is touch that. It becomes highlighted. You can only touch one at a time. So there's only a possibility of selecting one answer. That's it. That's all students had to do. And if you're thinking, wow, that was easy, you are correct. We had 86% of our students get that correct, which you might think, what about the other 14%? Not sure what they were doing. They might not know what a y-intercept is, but for the most part, our students were very comfortable with that concept. This was the first easiest, if we were to rank them from easiest to hardest based on percent correct, the first easiest item on the entire test. Every test needs a first easiest. This one happens to be it for this Algebra I STAAR 2025. Next, on number 16, we are looking at domain and range of linear functions. This is A.2a, and we have a little bit of a verbal description and a graph. And so what we need to do is we need to make sure we know exactly what we're looking for. We have an amusement park that has a per person uh, for admission and then $20 per car for parking. We need to find the relationship between P, the number of people in a car, and the total of car in the parking lot. So this is on its head a little bit because typically what we would do is we would uh, look at one of these and we would find a per person. And then we would, on the other one, we would find something that just says a flat rate or an initial rate. But look at they both have per. So you see how that is a unique situation here. We're going to have to definitely read read this problem to understand what exactly is our unit rate. And if we're thinking linear equation, we should be thinking of the slope-intercept form. We still need a b, right? Well, it's right here. It says that for purchase of at least one ticket, table shows the relationship between P, the number of people in a car, and C, the total cost in dollars, right? So what we're doing is we are just taking the number of people in a car. So that tells us we have one car. And so what that's actually telling us is that even though we have a $20 per car for parking, we're only dealing with one car, which means this happens to be our constant. And that means this is going to be our rate because we're talking about number of people. As the number of people change, the cost changes because we have a per person admission rate of 44.95, which means if we were to write an equation, it would look like this: 44.95 plus 20, as long as there's only one car. We would have to add another variable if there were multiple cars. But in this case, we've got just that one card. So then our x goes with our unit rate of 44.95. Now we need all that to kind of understand what's going on with the problem. We're simply looking at the range. Now they give us the range. the range. If we want to look at our x and y, we can look at it like this. P is our x, y is going to be c. We know this because of dependent and independent variables. So our independent variable is where we have our domain, typically our x values. We would graph this on the x-axis even though it's a p as our value there, and then we would have dependent variables. And that's going to be the cost because the cost depends on how many people show up. And so this is going to be our range. And so then our question is, most 4 tickets can be purchased. All right, so that's our maximum. And we would need to know that for purchases of at least 1 ticket. So let's see what they give us right here. So we have to have, it has to be, greater than or equal to 1. And we have to be less than or equal to 4 because we have at most. So we're looking at between 1 and 4. So that's what this is right here. So the range is asking, well, what are the possible values? Well, this is going to be, these two are the domain. So we're looking at B and D. And they look similar, except this one is what we call continuous. So if you were to graph this, right, it would look like this. This is what we call discrete. That means if you were to graph this, the line would be in the same location, but it would be filled with dots instead. So our question is, but they both go from 64.95 to 199.80. This includes all the decimals in between. This only has 4 distinct points. So our question is, can you bring 1.5 people to get a number between here? Can you get 3.29 people to get a number between here? No. In this situation, you can only bring whole numbers. 1 people, 2 people, 3 people, 4 people. Those are the amount of people that we could bring. Therefore, we only have 4 options in our range. Those 4. So we actually need the discrete data here because it's impossible to bring a decimal amount of people or get a decimal ticket. It has to be whole numbers. And so our answer is D. And that was obviously a little bit challenging. We had 48% of our students get that one. And look, we had 31% chose B. That means that they kind of got confused with the discrete versus continuous debate. And so sometimes it's as easy as looking at a table. Sometimes we need to look at the actual verbal description to know that we're talking about people. Has to be at least 1 ticket, at most 4 tickets, which means we're going to need discrete data. So this was definitely on the harder side. This was in fact tied for our 17th most challenging item on the test. Next, for number 17, we are evaluating functions. This is A.12b. As you can see, we have this equation editor new tech item. We just need to type in our answer. And so anytime we do that, that's actually going to make it more difficult than if we had an A, B, C, or D, or even a drag and drop or inline choice to choose from. So we have a function here, f of x equals, we have this expression over here, and we need to evaluate f of -1. Well, if we don't know what that means, we're kind of out of luck. We just have to guess. So let's talk about what that means. Well, this f of -1 is like this f of x. You notice that what we're doing is we're replacing x with -1, and we're saying specifically take this expression, 3 times the quantity x minus 4 squared minus 7, and evaluate that with x equals -1, so f of -1. So that simply means we're going to take this same expression and we're going to plug in a -1. We're going to leave everything else the same, and then we're going to simplify. That means that's the same as evaluating. Right? We're going to evaluate that f of -1. We're just going to plug in that -1 to x, simplifies. We need order of operations. So please excuse my dear Aunt Sally. Notice that multiplication and division are on the same level. You could do either one left to right, same with addition and subtraction. So parentheses always goes first. So let's deal with this -1 minus 4, right? And so that is going to be -1 minus 4 ends up being -5. Now we're going to do with our exponent. I have a -5 squared. That's not -5 times 2. That is -5 times -5, or -5 times itself 2 times. So -5 times -5 is going to be positive 25, because 5 times 5 is 25, and then two negatives make a positive. And now I'm going to do 3 times 25, because that's a multiplication. We do that before we do subtraction. And so that is going to end up being 75. And then we simply subtract that from 7 from that. We're going to end up with our answer of 68. So if we were just to do this, we would end up typing in 68. And then that would be all we needed to do, type in our answer. How did we do? Well, we only had 44% correct. The algebra itself was not that difficult. Students might have struggled with knowing what f of -1 means and how to evaluate that. If we were to just give them this expression, I'm pretty sure they would do a pretty good job with that. But f of -1, they had to know what that means. And then, like I said, not knowing that there's an A, B, C, or D to choose from really raises the rigor, because kind of feels like you're walking off the end of a pier and you're jumping into an ocean. You don't know whether you're anywhere close. That's why anytime you have multiple choice, it ends up being easier. So as teachers, what we need to be doing, taking those answer choices away, training our students to think about math and be sure about their answer without double checking, well, is what I came up with, at least one of the four answer choices. That trains them for problems like this, because this was a lot harder than it needed to be. In fact, this ended up being the 13th most difficult item on the test. And it's not hard math. It's simply because they didn't have any answer choices to select from. For number 18, we are writing exponential functions. This is A.9c, and we have a table of values, and we need to express that as an exponential function. All we are given are 4 points. Now, that's all we need. First, we need to understand that when we're looking at our reference materials, there's not anything there for exponential functions. We have factoring, properties of exponents, we have linear equations, we have quadratic equations, nothing about exponential. And so we need to come into this test knowing our standard form. So it's going to be f of x, or y, in this case it might be p of x, but that's fine, equals a times b to the x power. So we're not messing with our two variables. Really what we're messing with are that a and that b. And so this a is going to be our initial value, starting value, right? And we've already got that. This is what happens when x is 0. Because if you take anything to the 0 power, it becomes 1, right? So a times b to the 0 power becomes a times 1, because anything times to the 0 power is 1, which means it just becomes a. Therefore, we're always looking for what happens when x is 0. That's our y-intercept. That goes into our a. We've got it right here. It's 90. So we're going to say p of x equals 90. And so we can get rid of these two options. And then we are looking for our rate of change. So this is going to be our rate. Either it's a growth rate or a decay rate. It looks like as our x is increasing, our p is decreasing, which means we're looking for a decay rate, because it's going to be coming down like this, which means it's going to be a fraction. Not necessarily that it's going to be negative, it's going to be a fraction, which without any calculation, we see that we only have one fraction. Now we can calculate that if there were multiple fractions. What we do is we just look at the change of consecutive values. As long as we've got the x value changing by 1, which we do, right? The stepping of each of our x is going to be 1. So we can say 90 over 270 equals 30 over 90 equals 10 over 30. You see how what I'm doing is I'm just taking, as long as, once again, these are steps of 1, right? Uh, we can go ahead and just look at that as a single value. That's all going to simplify down to 1/3. And so we've got 1/3 as our rate. So this is our decay rate, 1/3 to the x power. So there we go. Our answer is C, but we could have figured that out just by recognizing it as a decay rate. This was definitely not too challenging. We had 65% of our students get this correct. And so 15% was our next highest, and we had the initial value correct, and it was just that decay rate was flipped, and they were moving this way, right, and looking at it as a growth rate. So this is definitely on the easier side, 10th easiest, and the challenge here is for students to recognize what our standard form of an exponential function is because it's not included in any of our reference materials. Next, number 19, we are looking at graphing functions and identifying features. This is A.3c. We have a simple graph of a linear function here, and we need to find the zero. All right, well, a zero is typically what we talk about when we're dealing with quadratics. So when we're talking about quadratics, right, a zero is going to be any place in which that quadratic function crosses the x-axis. We call them zeros. We call them solutions. They have three names we need to interchangeably use. We also call them x-intercepts. So we might not be that familiar with the term of a zero with linear functions, but if we know what a zero is with a quadratic function, it's going to be the same thing. A zero is a shorthand term for what x do we need to make, so x equals what to make y equals 0. That's where that term 0 comes in. If we want y to be 0, it's right there. It's -5. So this is simply a recognition of a feature. It's not any type of calculation needed. And so our answer is going to be right down there. It's going to be C. And this was definitely on the easier side. 77% of our students, they were able to recognize this. Now, 15% of our students, that's quite a bit if 77% got the correct answer. 15% got 10, and you can see where they got 10 from. That's the y-intercept. So we spend so much time talking about our y-intercept because we, in 7th grade, start dealing with the y equals mx plus b. We know that's our y-intercept. We almost forget the x-intercept until we get into Algebra 1. We don't think about that as being as important as the y-intercept. And so some students are just trained to look at the y-intercept. So we need to make sure that we know that there are other intercepts we need to deal with. But this was definitely on the easier side. This was our fourth easiest item on the test. Not surprising. It's simply recognition of a feature, no calculation needed. For number 20, we are factoring trinomials, and this is A.10e. We have an expression here, and we need to deal with this in two steps. First, when we take an expression, first thing we need to think about, we need to look at all the coefficients, and we need to think, is there any common factor of all of our coefficients? Because we can actually take that out, and we can put that off to the side. And if you look at it, all of these can be divided by 5. So what I want to do is I want to divide everything by 5. And then we can't just get it to disappear. What we want to do is we want to factor it out. It's the reverse of the distributive property. All right. So what we're going to look at is we're going to look at what happens if we do 5 divided by 5, 30 divided by 5, 80 divided by 5. We're going to keep all of our values the same. All right. So that's going to become x squared. This is a minus 30 divided by 5 is 6, minus 80 divided by 5 is 16. Now, these expressions are not equivalent until I show you what happens with that 5. That 5 gets factored out, and you put it on the outside, because if you wanted to bring it back, we can distribute. And we could easily go from here back to where we started. And that's what we have to be able to do. Generate equivalent expression, we have to be able to go back and forth if needed. So I've divided everything by 5, pulled it on the outside, encased the expression with parentheses, and now I can distribute that 5 back out. Now, this is looking more like a quadratic I can deal with. So we're looking for factors, and we're looking for factors of 16 that multiply to -16 and add to -6, right? So we're looking at 1 and 16, we're looking at 2 and 8, 4, and 4. That's the only way I'm getting the 16. And I could deal with this right here. I need it to be a negative 6. So I need this to be the negative. So let's look at it like this now. I have to keep that 5. I've got x plus 2. I need this to be positive, and I need this to be negative. The reason I want this to be negative is because that negative 8 is going to make a negative 8x, and then the 2 is going to make a positive 2x. That's going to give me my negative 6. And then I've got my negative 2 and my negative 8. That gives me my negative 16. So I have to look at all of that. And so that's how I would factor this. Now I'm looking for simply one factor, and that's it right there, x minus 8. It could have been x plus 2, right? They could have asked for the entire expression, which we would have had to show the 5, but there's that x minus 8. Now, how did we do with this? This one was definitely on the harder side. We had 41% of our students only get that correct. We had 34%. That's a lot. That's almost as many as the students that got it correct. Choose B. And so let's look at that. Obviously, we see the 8. It could have simply been a sign error, right? It could have been that they just did a negative 2 and a plus 8. They kind of flipped those two. And it also could have been that they were looking for a 0, right? So this is simply a factor. If we wanted to find a 0 or a solution, we would have had to apply this to uh, the 0 product property. We would have had to set that equal to 0. We would have had to add 8 to both sides, and we would have gotten a 0 of 8, or a solution, or an x-intercept, however you want to describe it, of 8. And so they might have taken it to that next step and thought of the positive 8, and that would have been a solution. So that also could have been something that messed up our students. But either way, this was definitely on the harder side. This was the tied for our 8th most challenging item on the test. So I think that first step might have tripped up some students factoring out that 5, and then making sure we're stopping at looking at the factor, not necessarily trying to get all the way down to a solution or a 0. Next, number 21, we are looking at attributes of quadratic function graphs. This is A.7a. Let me scoot this down a little bit. And we have a graph of a quadratic function. And we're looking for the axis of symmetry. Well, we can identify it by symmetry, symmetrical. How can we draw an imaginary line here and fold our graph in half so that it's the same on both sides? Well, you can't do anything side to side and have that flip upside down, right? If you do something like that, that's not going to work because it's not symmetrical uh, above and below that line. So what we need instead is we need an axis of symmetry that is vertical. And you see it has to go right through the vertex, and you can now fold it either side, okay? And it would be exactly the same. That's one of the features of a quadratic function, right, is you can fold it in half, and it goes right through the vertex. And so what point is that at? Well, that's at negative 5. If I could draw that straight there, right? And that's the x value. X equals negative 5. And that's all we're looking for. We're looking for what x value do we need in order for it to be exactly the same on either side. And that would be x equals negative 5. So that is our answer. We had to recognize what that term means, axis of symmetry. That means we're looking for a point of reflection. And so we only had 59% of our students get this correct. We had 16% of our students choose B, and we see this negative 3 as a given point. Now that point doesn't do anything for us. It's just there. It's probably used to distract us because that point is not important really in any way. And then we've got these two, y equals negative 7, y equals 2. Now we're not going to have a y equals, but look at this y equals negative 7. You see how that goes through our vertex, that goes through our minimum. And so perhaps students were looking at that because they know that a maximum or a minimum that runs through the vertex is also an important feature of a quadratic function. That could have been something that kind of tripped up our students. And so that goes back to reading and understanding exactly what it's looking for. So this was definitely on the easier side. This was tied for our 19th easiest item on the test. And for number 22, we are looking at equations for parallel lines. This is A.2e, and they give us the equation of one line, y equals negative 3/5 x plus 6. So if we were to do a quick sketch of that, we would do something like this, and we would say, all right, so we know we have the x-intercept, or excuse me, the y-intercept of 6, and it's got a negative slope, negative 3/5, so it might kind of do something like this. And we could say this is going to be line n, and the equation is going to be y equals negative 3/5 x plus 6. Line P is parallel to that. And so it's going to pass through a certain point, 15, negative 6. So it's going to be over here somewhere, not sure without calculating whether it's going to be above or below. So let's just pretend it's above. Doesn't really matter. What we want to see is that it is parallel, which means we don't necessarily know anything about its slope, its y-intercept, or possibly an x-intercept, but we do know its slope because it's identical. If it's parallel, parallel slopes are identical. So that means we know that the m equals negative 3/5. And that's really all we need to know. We want to write an equation for line P. Well, our equation is going to be slope-intercept form. It's a two-point problem. Y equals mx plus b. And I've already got my m. My m is going to be negative 3/5. Now, that's not in any of our reference material, so we need to know that parallel slopes are identical. Perpendicular slopes, we have to deal with that. Sometimes those are negative reciprocals. So if this was perpendicular, it would be positive 5/3. Just flip it and change the sign. Well, I need to find the b. I'm halfway there. So I can go and put my negative 3/5 there without having to calculate anything. I need my b. Well, I'm going to use this point that it's going through, and I'm going to plug that into my x and y, and that's going to give me 3 of my 4 variables, right? So my y equals negative 6, my x equals 15, my m is negative 3/5. The b is what I'm looking for. Well, I can simplify and solve for b. So that's going to simplify to 1 and 3, so that's going to be negative 9 plus b. Let's add 9 to both sides. That's going to be 3 equals b. So this was actually incorrect. This actually goes below. We would actually make our line go down there. But it was just a sketch to kind of get us an idea of what we needed to be. That would actually be 3. So there we go. That is our answer. We simply wanted to find the b. The slope was given to us if we need to recognize that we had identical slopes because they were parallel lines. This is a 2-point problem. Let's see how we did here. We actually had 45% of our students get both points, and we only had 24% of our students get 1 point. So if we take half of the 1 point, at that, we're looking at about 57% of our students getting this correct. We had 31% of our students not get any points. And as long as we know our vocabulary, parallel lines, we all should have been able to get that negative 3/5 without any type of calculation required. So this was right in the middle of the test. 24th easiest, but it's a 50-item test, so that's kind of right in the middle. The biggest thing here is we need to make sure we kind of drill down on parallel lines, perpendicular lines, and what that means for our slope. For number 23, we are multiplying polynomials. This is A.10b, and we simply have two different binomials. We need to use the distributive property, and in this case, since they're two binomials, all right, let's go ahead and use our FOIL. So that's first, that's outer, inner, and then last. So that kind of gives us our order of multiplying here. And so our first terms would be the 2k squared times this 3k. And then let's do the outer 2k squared. And so we'll just do plus on everything. We'll capture that minus within the term itself. So plus 2k squared times -4. So that's going to end up being a minus, but that's fine. Inner, right, is going to be the, and I'll just, like I said, once again, go and do plus uh, -3m and -3k, or just +3k, excuse me. And then plus, and I ran out of room, I'll put it down here, last, right? So let's do 3m and -4. Okay, so -3m and -4, which both of those will end up becoming a positive. So there's our multiplication. What we need to do is we need to simplify each pair there and then combine any like terms. So if we look at over here, I've got 6k, so the 2 times 3 is 6. K squared times k is going to be k to the third because it's the multiplication. Right, we see this right here. We're looking at our powers. It's the product of powers. So a to the m times a to the n equals a to the m plus n. You end up adding the exponents. And so this is like k to the 1. So k to the 2 times k to the 1 is k to the 2 plus 1, which is k to the 3. So that's where this 3 comes from. I'm going to go ahead and make this a negative here. So it's going to be the coefficients, or the numbers, are going to be +2, -4, that's -8, and then the k squared just gets thrown in there. I've got a, let's go ahead and make this a minus. 3 times 3 is 9. M times k is just km. When you have two different exponents, put them in alphabetical order. And then I've got a -3, -4, that's going to end up with a +12m. So that's all we have. And I'm looking to see if there's any like terms, and I don't see any like terms. So this is literally all there is. And we set our answer there as C. And how did we do? Well, only 50% of our students got this. I think the K's and the M's might have thrown some people off. We actually had 23% of our students get A. And so let's take a look at that. How do we get A? Well, if you just multiply your first and your last, right? So they just did the 2k squared times the 3k. That gets your 6k cubed. And then they did the -3m -4. They just dropped the outer and the inner. They just did the first and last, and you get your +12m. So that's how we got that. So they remembered something about the first and last. They just forgot the outer and the inner. So FOIL definitely does take a little bit of practice because there are 4 different multiplication, smaller problems you need to come up with. This ended up being slightly on the more difficult side. This was tied for our 21st most difficult item on the test. I think the biggest thing is just recognizing when we do need to use the distributive property and it's 2 binomials. Let's pull out the FOIL and go and write out the 4 different steps, knowing that you need 4 different smaller multiplication problems. Next, for number 24, we are looking at solving systems of equations. This is A.5c, and we've got 2 different systems of equations, and we need to come up with a solution. Well, there's a few different ways we can solve this: substitution, elimination, we could graph it. And so let's go ahead and do substitution simply because it's lined up for that, right? We can substitute this y into there, and instead of the 6y, we can do 6 times this quantity. If they were both in slope-intercept form or slope both in standard form, we'd have to do a little bit of manipulation to use the substitution, but it seems like they're setting it up for us. So let's do that. We're going to do 3x plus 6, and then instead of y, I'm going to use this -0.5x plus 4 equals 24. All right, so this is the original, right? The 3x plus 6 equals 24. And then I swapped out my y with it, -0.5x plus 4. So we just need to distribute 6, 6 to the negative 0.5. So 6 to half of 6 is what that's asking for, is 3. So negative would be negative 3. And then 6 times 4 is 24. Well, positive 3x and negative 3x actually eliminate each other, so I just get 24 equals 24. What does that mean? Well, it's true. So that means that there's no variables? No, that means that we actually have infinitely many solutions. If you get something like 12 equals 24, that's not true. That means you have no solutions, right? And so, or if you were to get x equals 5 or y equals 3, then you would get one solution, right? So these are the different options. Let's graph this just to verify that we're going to look at the exact same line. But I do want you to notice something. And we'll put this in Desmos here, that when we graph, we're going to have an issue with this second one. Okay, so if we wanted to type this one in, we can say y equals, and then negative 0.5 x, and then we'll get a plus 4. Okay, that looks good. Now, if we try to graph this other one, 3x plus 6y equals 24. You notice we get that little caution symbol. It's just on this test mode right here. It says implicit equations and inequalities is disabled. What does that mean? Well, it means no standard form. Let's go ahead and solve this for a slope-intercept form. So 3x plus 6y equals 24. So we're going to take the 3x over here. So 6y equals negative 3x plus 24. And let's divide everything by 6. And so we're going to get y equals negative 3/6 x plus 24 over 6. All right, so we could do that. So let's go ahead and change this here. And we will put what we have here. We'll go ahead and put in that y-intercept form, that slope-intercept form. So y equals negative 3 over 6. Oh no, let's do that. X, get rid of that little guy right there. And then we need a plus 24 over 6. Now, I didn't simplify this because if you simplify this, you're going to notice, look, they're on top of each other. It's the exact same. And so the fact that they are the exact same, if you take it off, you see the red, put it back on, they're the exact same. Why? Well, because what is negative 3/6? Negative 3/6 equals negative 0.5. What is 24 over 6? 24 over 6 equals 4, which is exactly what we have right up there. So it is the exact same equation, which means they touch infinitely. So they are infinitely many solutions. And algebraically, what that looks like is that it's always going to look like what we have here, where we have this 24 equals 24. That's what it looks like when you get two numbers that equal each other. It's a true statement that gets you an infinite solution. So we only had, this was rough, 32% of our students get this correct. We had 35% of our students get the incorrect answer of B. That's more than the correct answer. Now, they probably didn't work it out. They might have gotten stuck on graphing it and they got that error message. They couldn't graph the other one. When we typically do systems of equations and they're linear, how many solutions do we normally have? One. That makes sense, except when it doesn't. So we need to find other ways to solve it because it's not always going to be one, but that's the most common answer when we find things like this. Or they might have found one viable solution and they didn't check to see if other ones work. And so they just, they just kept going. They might have said, oh, well, if I, substitute in a 0 for x, right, I'm going to get a y equals 4, right? So they're like, okay, so 0, 4 works. And then they put that into here. They say 3 times 0, 6 times 4, because you can kind of do that without calculation. And they're like, hey, look at that, 24 equals 24. It works. They didn't check on any other solution. They didn't realize that there are infinitely many solutions. So this one was definitely on the more challenging side. We looked at how to solve it algebraically, how to solve it with graphing. There's a little bit of manipulation because the Desmos calculator does not allow you to do those implicit equations in standard form, at least in the test mode. This was hard. In fact, this was the fourth most challenging item on the entire test. So we do need some extra practice on some of those exception problems to where it's not just one solution. Next, number 25, we are writing linear functions. This is A.4c. And what we have here is we have a restaurant owner. We're looking at different prices, and as the prices change, the numbers sold get changed. They don't give us these numbers in order, and we need a line of best fit. We need to make some predictions. All right, so let's do this. Let's go ahead and just open up our calculator. Let's get this table of values in there, and let's get that out of there so we can see what we're doing. Yeah, let's do this. Let's go ahead and just add the plus, and we're going to add a table, and we're just going to add these values. Now, what we don't need to do is we don't need to add the extra zeros if we don't want to. So what that means is we can just add like 6.5, 9.5. We don't need the 0.0. We do need, obviously, the 7.25. We're just going to type in all of these. 11 is fine, 8.75, 9.35, and then we're going to go over and type in the y values. And 107, 78, 99. You want to make sure you line everything up. And then 80. Okay, so we've got this. Let's just open it up here. Let's see what we get. And if you think we don't see anything, it's because we're zoomed in too much. All right, so let's get into here. And we do kind of see a linear relationship. So that makes sense. Okay, so that makes sense. It looks like as the our x values, let's get that locked in right there. There we go. So for our x values, what are they? The prices. So as the price increases, it looks like our numbers sold, that's our y, decreases, which makes sense. The more expensive you get, the less people are going to want to actually, do anything. All right, so let's look at some predictions and let's see which one of these make sense. Okay, so approximately 82 lunch specials will be sold at the price of $5. All right, so let's take a look at that. If we get into $5, we've got our line of best fit that we can add right there. Does that make sense? Well, we can take a look at it on the line, and that would help. Or we do have a basic equation that they give us. So we've got two options. Now, that's quite a bit of calculation there. But if we want, we could plug in each of these, these x and y values together to see if it makes sense. Or we could just take a look at a line of our best fit. So realize that once you get that line of best fit graph there, then you can go and just use this equation if you want to. All right, so let's take a look at what we have. So 82 lunch specials will be sold if the price were, what is our price that they're asking us for? They're asking us for $5. All right, so let's look at $5. It's going to be right around here. You see, I'm just dragging it on here. $5 is, it looks like about 120, and they say 82. No. All right, so 111 lunch specials will be sold at the price for $6. All right, so let's just drag it. Let's get to $6. And it looks like, hey, look at that. That works, about 111. Okay. So that one definitely works. So we are going to go ahead and put a check mark on that one right there. And actually, let's just go ahead and just throw it in there and get the correct answer. All right, so let's get this off so we can go ahead and just check that. And we got two that we need to get here. So let's look at 102. If the price were, I think that says 750. Okay. So 750 is going to be right here. Ooh, 97. No, that's not going to work. The price for 1250. So we're looking at our X value of, oh, 1250. That's expensive. That's more than they've done. Price, the number would be 74. Now we're guessing almost 51. And the last one is if it were 15 bucks, that's very expensive. I don't recommend that. You're going to get about 28. Yeah, that works. Look at 15. We've got like 27.6. Okay. So it's going to be these two. And once again, I used my line of best fit. Also could have just used this equation that you see right there, plug in all the x values, but that would have done a lot of calculating. So how did we do on this overall? Well, this is a 2-point problem, so we get partial credit and we get full credit. But this was not necessarily as hard as we would expect because of the ability to get partial credit. So we only had 36% of our students get full credit. That's not very difficult. Well, that's not very good. But we had 44% of our students get partial credit. So they got at least one of these correct. You take 22 or half of the partial credit, put it on the full credit, and you're going to get 58%. So overall, that's not horrible. We've definitely seen worse. And 20% got nothing. So this ended up being on the easier side, though it's still kind of middle of the test, tied for our 21st easiest item on the test. And really, this is a problem that becomes very simple if we can plug it into the calculator. So that's a skill that students might need some extra practice with. 26, we are solving quadratics, and we have an equation. We use to find the width of a rectangular deck as an area of 108. What is the width? You might be thinking we're missing some numbers or some dimensions. Let's draw it and we'll figure out what we're talking about. And this is A.8a. So we're taking what we know about algebra, we're applying it to geometric situations here. And so if we see the equation for area, how do we find area? Area equals length times width, okay? And in this case, they give us the area of 108, all right? And then they give us the width, all right? So the width is x. So I can use this equation, x times x plus 3 equals 108. Well, let's take a look at what we have. If we have the area 108 equals an unknown width times x, because they give us the width of x, and then they say we can use this equation, 108 equals x plus 3, or x times the quantity x plus 3. Well, guess what that means? Guess what that missing length has to be this x plus 3. So they don't come out and tell you, but with the equation they give you, they let you know since you find the area by length times width, and since the width is x, and the equation x times the quantity x plus 3 can get you there, x plus 3 has to be the length. Now, we need to find the width. The width is x. So let's just solve for x. So we do all that. That kind of gives us context. We still end up having to make a quadratic. So we're going to get x times quantity x plus 3 equals 108. So we distribute this out. We get x squared plus 3x. And you know what? Let's go ahead and subtract 108 from both sides. Because if we do that, guess what that looks like? Now that's a quadratic equation, but it took us quite a while to get there. We need to find factors of 108 that will multiply to 108, negative 108, and add to positive 3. And so after a little bit of trial and error, you will find we can do a plus 12 and a minus 9. 12 times 9 gets you 108, plus 12 minus 9 gets you a plus 3. And that's going to work. Now what we need is x equals the zero product property, right? Go ahead and put them equal to 0. X equals negative 12 and x equals 9. If you set those equal to 0 and then get the the constant over to the other side, right? It kind of flips. How do you have two answers? Well, this is a real world problem. It's a rectangular deck, so sometimes we have to evaluate our answers. And what we can't have is a negative length. So sometimes we're good with just taking one of the possible solutions because in the real world situation, only one of these is viable, and that's going to be your +9. So we had to do quite a bit of work to get there. And this was kind of middle of the road in regards to difficulty. This was the 25th, and since it's a 50-point item, a 50-point item test, we'll say it's the hardest slash the easiest because it literally is right in the middle, or it's tied for being right in the middle. So it took a little while, but if we can just get this multiplied and get it into a quadratic, it becomes something that students are pretty familiar with. We had 56% of our students get this correct, but take a look at our answer distribution of the incorrect answers. If those are so similar, that means we're just guessing. So we either knew it or we didn't. And there's this real world application that definitely made it a little bit more challenging for some of our students. Number 27, we are looking at slope. We're determining slope. This is A.3a and pretty straightforward. We've got 4 points. We need to find the slope. A few different ways we could do this. We have our slope formula. Right, our slope formula is in our linear equation sections of our formula chart. And it's m equals change in y over change in x. So we can do it that way. That works. Change in y over change in x. So let's just say, and I'm going to use the easiest numbers to work with. So these numbers look good. I'm going to make this my y1, y2. Doesn't matter if you flip those. Just match up your x1 and your x2 appropriately. So my y2 is going to be 7. Y1 is -1, so 1 minus -1, that'll end up being a +1. That's fine. And then I've got a 2 minus 5, so that ends up being 8 over -3. And you see, we had to get there, but there's a lot of different options there. So this is 8/3, and I got that negative, so we're going to end up making this a -8/3. Now that's one way to solve this. You can just go ahead and just calculate what are we doing here from 23 to 15 is going to be, if you subtract those two, it's going to be an 8, right? And then if you go from -4 to -1, right, that's going to be a -3. And so, but that's the problem. If you do it by hand, you might end up doing it 8/3 because they're 3 away from each other. But you end up having, you have to subtract those two. -4 minus -1. That's how I did this, was 23 minus 15. So I do suggest writing it all out rather than doing it by um, just by the eyeball test, because I could easily see how someone thinks of that as a 3 because they're just 3 away from each other. Um, and so what we're looking for the change between those two, and it's a change of -3. So we had 67% of our students get this correct. That was pretty good, and then the rest was kind of lower. This definitely was on the easier side. In fact, this was tied for our 6th easiest item on the test. Number 28, we are looking laws of exponents. This is A.11b. We have drag and drop here, and we need to just keep our laws of exponents in front of us. So let's go ahead and just open that up. Bring it over here off to the side where it's not going to bother us. All right, so products, quotient, power of a power, rational, negative, all of that. So we need to form an equivalent expression, all right? And it looks like we only have one base to do with x. So let's kind of split this in half. All right, so I've got my 2 over 6, and then I've got my x12 over x to the -3. I can handle this easily. 2/6 simplifies to 1/3, and that's going to be my coefficient. So that's half points right there. I'm just going to grab this 1/3. Now I need to do a little bit of work on my x's. Okay, so my x's, I have something in my denominator here, but I can also use my quotient of powers. My quotient of powers lets me just subtract the the powers, right? The exponents. And so I can say this is x to the 12 minus negative third. So x to the 12 minus negative 3, that's going to be an x plus 12 plus 3. So that's going to end up being x to the 15. Now, if you didn't want to look at it that way, there's another way to look at it. Because some of us might have thought, well, it's a negative at the bottom, which means we need to use our negative exponent. That's fine. So what we end up doing is we know that we have this negative down here, and we end up just putting it up on the top, right? That negative exponent becomes it comes, if it were in the regular exponent, it would become 1 over, but since it's already in the denominator, it flips back up to the numerator. So that ends up becoming x to the 12 times x to the 3. Then we can use our product of powers, and we end up doing the 12 plus 3. You end up getting the same answer depending on which way you kind of resolve it. But that's what we're going to end up with. 1/3 x to the 15th. This is a 2-point problem. And so those that got 2 points, only 24%. Now that's a little bit disappointing because it wasn't super complicated here. But what's more disappointing is that we only had 1 point students, 31% of our students got 1 point. So if you take half credit right there and put it there, you're looking at 40% correct, which definitely makes it on the more challenging side. That means we had 45% of our students unable to figure out this. Like, guys, we can do 2 over 6. If we're confused about the x to the 12th over x to the negative 3, I get that. That's part of what we're learning this year. We can do 2 over 6. So I think sometimes when we do this, we see the negative exponents, we kind of freak out. I think we can tell our students, guys, let's just look for our constants, our coefficients. Um, because you can at least you could have gotten half credit. If you could have just gotten the 2 over 6 becomes 1/3. This was the 7th hardest item on the entire test. Definitely needs more work. Next, we're looking at linear equations and the distributive property. This is A.5a. We need to find a value of z that will make this equation true. Now, we do have 4 answer choices, so if we want to use substitution, we can just plug and play, but potentially we could do this 4 times if the correct answer is that last negative 45. So let's go ahead and solve for z, and that will let us just do this once. So I'm going to write this here, and one thing I do notice about this equation is that z is on both sides, so I'm going to need to take care of that. And I do need to distribute out this negative 4. I'm going to go ahead and write that out. So negative 4 times 1/6 z, and then we've got a plus negative 4 times 9. That's going to end up being minus 9, or minus 36. So this ends up being negative 4/6. So negative 2/3 z minus 36. Then I've got a 4/3 z plus 6 still over here. So let's get our z's on one side. Let's make sure they're positive. So we're going to add 2/3 using the properties of equality to both sides. And that's actually going to be super helpful because that's going to give me 6/3 z. And 6/3 is the same as 2. So we can finally get rid of this fraction here. Let's go ahead and subtract 6 from both sides. So minus 6. So I'm going to get 2z equals, then I've got negative 42. When you subtract from a negative, it's like adding the 2. Then you simply divide by 2, and we're good to go. Z equals negative 21. So our answer is B. If we would have just plugged and played, we would have gotten the second answer, so that wouldn't have been too horrible. But sometimes you're not going to get 4 answer choices to choose from, which means you always need to be able to solve for a variable on its own. So this wasn't too difficult. We had 58% of our students get this right, and our answer choices were kind of split between A and C. And this definitely ended up on the easier side. This was 20th, 21st easiest tied for the 21st easiest on the test. And it was Not super difficult, but once again, if we take away these four options and we make it like a drag and drop that's got more than four options, or maybe even just an equation editor, we have to type in the answer. That definitely makes this a lot harder. Next, number 30, we are graphing inequalities. This is A.3D. Now, this is definitely a new item type. Notice what we have here. We've got to graph this, and there's these buttons on the left. We've got to make sure we hit the solution set, and we've got to figure out what the graph is. So let's start with just this. It seems like it's pretty simple. Okay, y is greater than 5x minus 3. So let's figure out where some of our intercepts would be. Okay, so if we were to treat this as an equal sign, let's do y equals 5x minus 3. We could do a few things here. First, we can find our y-intercept. So our y-intercept would be minus 3. If we want to get an additional point, we can, put in 0 for y and solve, or we can just use our slope. Our slope is 5. So remember, that's rise over run. So we're going to go up 5, 1, 2, 3, 4, 5, and then over 1. That's what the positive 5 slope means. So it's going to go up through this 1, 2, 3, 4, 5. Here's another point, and then 1, 2, 3, 4, 5. Down here is another point. All right, so we're going to get a line. It kind of goes through here. Kind of sketch that. So let's get that first. Let's get that graph at. We're going to put a point there at -3. And our next point is going to be at 1, comma 2. All right, so that gets us that line that we were looking for. So that's half the point. Now let's deal with the inequality. Since the inequality is just simply greater than, if you're dealing with a greater than or you're dealing with a less than, it is going to be a dashed line, or sometimes we'll call it a dotted line. Depends on which. They're both the same. So these are going to be dashed lines. If you ever have greater than or equal to, less than or equal to, those are going to be solid lines because you can include the answers on the line in the solution set. In this case, we can't, so we need to change this from solid to dashed. All right, so now we have the correct line. Now it is at least dashed, but we're not done. We need to find the solution set because this wasn't an equation, this was an inequality, which means we need to shade either the left side or the right side. Okay, above or below the line. Well, greater than lets us know that if it's greater than, it's going to be above the line. Less than is going to be below the line. Now we can test that. So let's get this back over here. So we see we lost our line because we didn't click over. There we go. So there's our line. We need to click on that solution set. There we go. So now on the solution set, we can select whether we want to go on above the line or below the line. Now you can't flip back and forth, so if you want to take this one off, you have to click it again. And now we want to go above the line because it's greater than. How can we test this? Well, let's find a point. The easiest point is always origin. This should come up with a true statement because the origin is within the solution set. So let's just substitute y equals 0, x equals 0. So 0 is greater than 5 times 0, which is 0, minus 3. So really we're looking at 0 is greater than -3. And yes, here's -3, here's 0. We're thinking of greater than being on the right. So yes, 0, 0 is part of the solution set. So that is our answer. Now, that involved quite a bit of work and quite a bit of thinking. How did we do? Well, we had 24% of our students get both points, which is about average. I think the scary thing here is that we only had 8% of our students get 1 point. Typically, it's that half credit that really boosts these multiple point problems into being not so horrible. So you take that half credit, you're looking at 28% correct. 67% of our kids, 2/3, got nothing. They couldn't even graph this, couldn't even look at this as an equation in the slope-intercept form, at least get a line on there. And so this, in case you're wondering, is definitely our hardest, by far, most difficult item on the test, graphing inequalities. It's part of it's the technology. It's not a super complicated inequality, right? We're not needing to simplify or anything like that. It's not like it's in standard form and you have to isolate it. It's in slope-intercept form. And so students should have many avenues into getting into a problem like this. We just need to slow it down into steps, right? Looking at it as if it were an equation, plotting a point, deciding if it's solid or if it's a dashed line. Then understanding that greater than means you're going to go above the line, less than means you're going to go below the line for the solution set, and always testing it with 0, 0 just to verify. Those are the steps. Practice, practice, practice. Number 31, we are looking at properties of equality. This is A.12e, and we need to find an equation that is equivalent. Well, that's something that we have to deal with all the time. We've got something in standard form, and we need to change it into slope-intercept form. All right, so how do we do that? How do we isolate a variable? Well, what we do is we use the properties of equality. So this is A.12e, like I said, and let's just say we need to get that y isolated because you notice all of our answer selections, right, are y equals. So basically we're taking standard form and we need to translate it into slope-intercept. All right, so something we should have lots of practice with in 8th grade or in 9th grade, depending on when you take this Algebra 1 exam. So we're going to take this. First, we want to get y by itself. So we need to take this 5x. We need to move it to the other side. So that's a positive 5x. So we're going to subtract 5x from both sides. Can't do anything with the 5x and the 40, so they don't really simplify in any way. You're going to get negative 8y equals. Always get that 5x first, right? Keep it with the variables first, the constant second. So now I've got this, and now I simply need to get rid of that negative 8. It's negative 8 times y, so we're going to divide by negative 8. And we can just divide each of these terms by negative 8. It's the same as dividing the whole thing by negative 8. So let's just look at it one at a time. So those two are going to cancel out into 1. So we're going to get y equals negative 5 over negative 8. So it's going to be a positive 5/8 x. And then I've got a 40 divided by negative 8. Well, 40 divided by 8 is 5. Since one of them is negative, it's going to be minus 5. So y equals 5/8 x minus 5. And you see we had all kinds of 8s and 5s over here. And so our answer here is D. And that seems like it might be a little bit obvious, but obviously not everyone got it. It actually ended up being less than half correct. We only had 47% of our students get this correct. We had 25% of our students get B. So that was our biggest incorrect answer. And that was really a sign error, is what that was, is we ended up with, you can get all the way down to this point right here. And you notice that all the signs are reversed, right? This is a negative 5/8. This is a positive 5/8. This is a positive 5. This is a negative 5. What they most likely did is they divided, but they divided by 8. They didn't divide by negative 8. And if you divide all of this by 8, obviously, let's just pretend that that goes away. This becomes a negative 5/8, and this becomes, right, positive 5. So there are some students that they know exactly what to do, and what they messed up on was simply getting the correct sign and dividing by that negative 8. So this was on the harder side, probably didn't need to be 16th hardest, but this did involve quite a few steps. And so there's a lot of opportunities to, unfortunately, make a mistake. Number 32, we are looking at quadratic domain and range. This is A.6a. And you can see we have a truncated quadratic graph here, right? It doesn't go on forever. And so that's typically what we're going to see when we have a quadratic domain and range, because the domain of your traditional quadratic is going to be all real numbers, and so that's never really a challenge. And so they have to cut it off at certain points, right, to make it kind of difficult for us. So first off, we're looking for the domain. So the domain is the independent variable, and those are our x values. So we're looking side to side, okay? So it goes from, here we go. We've got 5 right here. So x is going to be less than 5 because it's everything to the left of 5. It is a closed circle, so we'll call it less than or equal to 5. And since we've got this arrow up here, that means it extends forever. So there's no other ending point that we would need to say x is greater than something. It's literally just all real numbers less than or equal to 5, because 5 is going to be our highest point that you would see on the domain. So our answer is A. So it's more of an identification problem rather than a calculation problem. And this definitely was a little bit on the easy side for our students. 60% of our students got this correct. Now we had 15% choose B, right? Is 14%. That's a normal quadratic, all real numbers. And then we had 10% choosing, all real numbers greater than or equal to 1. You see that's our minimum or right here. So they might have been looking at range. So our minimum is all real numbers greater than or equal to 1. And so this definitely was on the easier side with that 60% accuracy. In fact, it was the 18th easiest item on the test. For 33, we are graphing again, and specifically we're graphing exponential functions. This is 8.90 because look at the problem we have, but this is an interesting one because we have to select which type of graph we have. So first we have to select, is it linear, is it quadratic, is it exponential? So before we do anything, we should see this is going to be exponential. Now, we don't have the standard form of exponential functions in our reference materials, but we've been working with this. And our standard form is f of x or y equals a times b to the x. Now, this is what we need to know. And it's that x in the exponent that lets us know it's exponential. So that's our clue that it's an exponential function right here. So we know it's an exponential. We need to drag these. We need to find 2 points. We need to drag these 2 points. All right, so how can we figure out what this is? Well, we know 2 things about this. Okay, so we know that this A value, so in this case, we're talking about 6 because it's in that A position. This is our initial value, or in this case, it's actually going to be our y-intercept. So if we're dealing with compound interest, right, it's going to be the principal, it's going to be the amount that's deposited. But since we're dealing with this graph, it's what happens when x equals 0. Because if x equals 0, then what we get is f of 0 equals 6 times 1/3 to the 0, right? Well, anything to the 0 is 1. We need to know that about exponents. You take anything to the 0 uh, power, and it becomes 1. So then f of 0 becomes 6 times 1, which is just 6. So that's how we get our y-intercept. So I'm going to take this, I'm going to move this up to 6. Okay. Now, we need to find one more point. So it is going to slope down like this because our second point that we always deal with is our rate. And in this case, it is a decay rate because it is less than 1, right? If it's greater than 1, it's going to end up going up like this, but it's not. It is a decay rate, which means it is going to slide down like that, but I don't know exactly where until we plug in another value. So let's look at f of 1. All right, so I'm going to plug in 1 into my equation. And so I'm going to say 6 times 1/3 to the 1. I picked 1 because I don't have to do much with that. Anything to the 1 is itself. So then f of 1 becomes 6 times 1/3. So we have to know our laws of exponents to make this work, which equals 6/3, which equals 2. So that's my second point. If I get that right there, I now have my exponential function. So the 2 points that I took were x of 0, y at 6, because I get that from this right here. And then I took f of 1, and it came out as 2. You can continue to do more points, but then it's going to get into, you know, values that are fractions that get really, really small, and it's just going to be impossible. So we need those 2 points. And if we have those 2 points, that's it. That's the graph. Now, this becomes wrong if you're not even choosing exponential functions, if you're choosing linear quadratic. And 1 point is pretty obvious, but you have to do a little bit of thinking to figure out that second point. This was a 1 point item. You either get it right or you get it don't. Getting 1 point right and the other point wrong generates the wrong graph. So we only had 34% of our students get this correct. This was definitely hard. And we don't see this type of question very often. So this is something that students need to have a chance to practice of graphing these exponentials because they're a little bit harder to graph because of the asymptote, right? And so we need a little bit of extra practice on this, finding 2 points. And then honestly, we can sketch these by hand if we can evaluate our growth rate. Is it a growth rate or is it a decay rate that's going to let us know whether we're increasing or decreasing as we move from left to right? So this was definitely on the hard side. This was tied for our 5th hardest item on the test. Next, for number 34, we are writing systems of equations. This is A.2i, so we have this verbal description that gives us a real-world scenario. We need to put this into 2 systems of equations. All right, now, it might seem easy because normally they just give this to you, you put it right out there, but this is a lot harder than it seems. So the perimeter of a rectangle garden is 48 meters. All right, so I'm going to do this. I'm just going to draw a rectangle, and I'm going to say P equals 48. Cool. The length of the garden, y, is 6 meters more than twice the width. Whoa. You see how that becomes difficult? Okay, so let's slow this down. The length of the garden, y, put that right there, is 6 meters more. So 6 meters more than twice the width, which is x. Okay, so twice the x. So 6 plus 6 to twice x. That's going to be my length. Okay, so that y is going to equal 2x plus 6. Wow. Okay. So that's what that y is. And then my width is just x. Okay. So if I wanted to solve this, right, I can either do, 2x plus 2y, which kind of helps, but then, I need to know what the other one is. Or we could use this right here, this y equals 2x plus 2a. Okay. So let's get the first part. How do we solve for perimeter, right? So let me just draw it like this. That's x, that's y. Well, what you do is you double the x, right? You double the y, 2y, 2x, add them together, you get your perimeter. In this case, our perimeter is 48. So that's one equation we can use. I see that here, and I see that here. Doesn't work here because you have to double the length, double the width. We've been working on that since the 3rd grade. The other one is going to be this kind of monstrosity, right? What does y equal? And so we can take y, and we can substitute for y 6 more than, so that's a plus 6, twice x, twice the width, which is x. So that 2x plus 6. And so you see we've got that here, and they flip the 2 and the x, or the 2 and the 6 there. So that doesn't work. So our answer there is C. But those verbal descriptions definitely are going to throw off quite a few students. We had 34% of our students get this correct. This was definitely a challenge. We had 39, that's more, choose B. Now, why would we choose that? Look at this. They did the hard part. They got the y equals 2x plus 6. That's the hard part. You know what they messed up? Students that chose this, something that they learned in 4th grade. The formula for perimeter is double the length plus double the width. They didn't double the length and double the width. They just added x plus y. So a simple mistake. got more students to choose B than the correct answer of C. This was definitely difficult. This was just like the previous question. Fifth hardest item on the test. Definitely a challenge. Next, for number 35, we are graphing functions and identifying key features. This is A.3C. And we've got 4 different graphs here. And we simply are looking for slope of 2/3, y-intercept of 4. All right, that should be fairly simple. Let me copy those down here. So m equals 2/3, and then b equals, what do they say? 4. All right, so I'm going to go with the b first. Let's eliminate anything that doesn't have a y-intercept of 4. All right, so this got a y-intercept of 3. Wrong. Y-intercept of -3. Wrong. Y-intercept of 4. Okay, possibly. Y-intercept of 4. Possibly. All right, so I'm down to 2 problems. And I don't even need to do any calculations because look, this is going to have a negative slope. If it goes down from left to right, this can have a positive slope. It goes up from left to right. We can identify the sign of the slope based on whether it goes down or left when you go down or up when you're going from left to right. Well, my slope is a fraction, but it's still a positive fraction, which means it's going up, which means the only possible answer is B. So we don't have to do any calculations. We can immediately know D is our only option. Now, that did not take a lot of work. Let's see how our students did. Overall, not bad. 61% of our students were able to get this. 20% got this on B, and they got the y-intercept correctly. They just messed up the slope. This was a negative 2/3 slope, and we needed a positive 2/3 slope. So they missed that easy identifying it's a slope positive or negative. We had 11% of our students choose A, 8 choose C. So this was definitely on the easier side. This was tied for our 14th easiest item on the test. For number 36, we are solving quadratic equations. This is A.8a. When we do see this exponent 2, that lets us know we're dealing with quadratic. And it's actually going to be a lot simpler than we think because we don't have to move that 25 or factor or use the quadratic formula. We can take the square root because we're wanting to find the solutions, which means we're wanting to isolate x. And if we take the 2x plus 1 squared, right, the opposite of that, the inverse of that, would be taking the square root of that because the square root would then cancel out that squared. So that works as long as we could do the same thing on the other side, and 25 happens to be perfect squares, so taking the square root of 25, that's going to work. So what we end up getting is 2x plus 1 equals, now it's not just 25, it's plus or minus 25. When we take the square root of something, we need to take plus or minus because if you were to reverse engineer this, right, 5 squared equals 25. But so does negative 5 squared because the two negatives make a positive. So that's why we need to take both positive and negative. So then let's go ahead and split this out into 2 separate equations. 2x plus 1 equals 5, and then 2x plus 1 equals negative 5. And we're just going to subtract 1 from both sides in both equations to get that 1 out of there. It's going to be 2x equals 4, and 2x equals negative 6. Divide by 2. That's going to leave that coefficient of 1. X equals 2. And then x equals negative 3. So let's grab those. You can put them in either position, 2 or negative 3, or you can end up flipping them and you can say negative 3, 2. Order doesn't necessarily matter on this one, but that is going to be our correct answer. Now this is a 2-point problem, and we have 34% of our students that got both points. We had 42% get just 1 point. So most likely they were just thinking of this positive root right here. They got the 4, they got the down to 4, they divided by 2, and they got this right here. They probably got this. They might have struggled with this over here because they didn't necessarily see. And when you take the square root of a number, you need to take both positive and the negative as a possible solution. So that's the challenge there. And then we had 25% of our students get nothing. So half credit for that 42% gets us up to 55% correct. This was right in the middle, but ended up being slightly on the more difficult side. 24th hardest item on the test. Next, for number 37, we are looking at domain and range of linear functions. This is A.2a. And we have a graph and a verbal description we're going to need to take a look at. So we get the owner of a business as a delivery van, and then its value, right? So the second you drive a van off the lot, it becomes less and less valuable. It's called depreciation, and eventually it's not worth anything because it's old and beat up and has too many miles on it. That's how cars work. Now, we need to find the domain of this function. So let's find the domain of this function. Well, the domain is going to be our x values. So let's take a look at the x values. We have hard closed circles there, hard stops at 0 and 10. Okay, so x is going to be less than or equal to 10. And we're going to use an inequality because it is a solid line, so it is continuous data. Sometimes they're just dots, they're just points, then that would be discrete data. So this is continuous, and it's going to be greater than or equal to 0. So our time frame is from 0 to 10 years. That's what we're looking for. And you notice that A and B both have almost the same thing, except the difference is going to be this, right? That Y is our supposed to be for our range, but that's not even the range, right? That's the domain with the Y in there. This is our correct answer of B. Our actual range is right here. And so we had 25% of our students choose the actual range. 58% get the correct answer. We weren't really distracted by A or D. So this was definitely on the easier side. This was the 21st easiest item on the test. And so that was not super difficult, even though we had all of that verbal description at the top. We didn't really need any of that. We can grab everything we needed to simply from the graph. 38. We are looking at solutions for systems of inequalities. This is A.3H. All right, and so we are going to have some graphs here. We got two different inequalities. And so let's take a look at our possibilities here, because we can go ahead and get rid of two of them just by looking at the line. Look, I've got one of them is a less than, one of them is less than or equal to. So when I'm looking at less than, I need to look at a dashed line. Less than or equal to needs to be a solid line. So I'm looking for graphs that have one of each. All right, A could work, B could work, but look at C, two solid, gone. D, two dashed, gone. So I'm just going to write like this. I'm going to say A, B, C, and D. These are gone. And since they're right there, I could go ahead and just kind of bring those up so I can at least see them. All right, so now let's look at which graph is which. It looks like they're the same lines, and it looks like these are in slope-intercept form. So let's go ahead and just grab our y-intercepts. All right, so I've got a y-intercept of 4, and I've got a y-intercept of -2. All right, so they're both like that. And this one with the 4 is the dashed line because it's simply a less than, so that makes sense. So that's the correct line right there. That's the correct line right there. And then we've got the solid line on the line with a y-intercept of, it's got a -2 y-intercept and a -2 slope. All right, so we're good there. So those two are the exact same lines. It's the shading that is uh, different for both. So this first one is going to be less than. So if we're less than, we're going to be below this line. And also, if we're less than or equal to, we're below the line. If you're greater than, you're above the line. So we need to be below this line and below this line. All right, so A looks good. You know, B is opposite. All right, so let's pick a point and let's make sure it should be in the solution set. And so let's pick this right there. All right, so -2, 0. We're going to plug this in. It needs to now work for both of our inequalities because we think it's inside the solution set. Okay, so I'm going to plug it into the first one. So y is 0 is less than -2 plus 4. So 0 is less than 2. Check. Let's do the next one. And we're going to do 0 less than or equal to -2 times -2 minus 2. Lots of -2's. So that's going to be 0 is less than or equal to -2 times -2 is 4. Positive 4 minus 2. 0 less than or equal to 2. Check. All right, so that is in the solution set. So our answer there is A. Now, that was a little bit challenging, so let's see how our students did. We had 63%. So even with all of that work, we did pretty well. 63% get the correct answer. And then we had 18%, 14%, and 5. So not many people chose the D. I am a little bit surprised that so many people chose C, seeing as how C had two solid lines. We should be able to immediately tell whether or not it's going to work just by looking at whether the lines are solid or dashed. But 63% actually means this wasn't as difficult as I thought. This was our 13th easiest item on the test, and as you could tell, I didn't really have to calculate anything unless I wanted to check my answers. I could look by the greater than, less than, or greater than or equal to, less than or equal to inequalities to see whether it can be a solid or dashed line, and then I can identify the correct lines simply by looking at the y-intercept. And so that's not that difficult for our students. Next, number 39, we are looking at parent functions. This is A.7c. As you can see, we've got some drop downs that we're going to use for our inline choice. And so we have a quadratic function, and we're going to transform it. Now, we need to look at how it's translated. What happens with the 6? What happens with the 2? All right, so we could do this without any graphing, but we can always check with the graph. So what's going to happen when we do this? Well, when we're looking at parent function, right, we have our f of x equals x squared. Then you can always transform it simply by doing this. Now, g of x equals a, or now we don't have an a term here, but if we have an a term, it would be right there. And that's going to do some stretching and compressing. Okay. And then inside we have x minus h plus k. And so we're dealing with this h and this k. So what the h and the k does, this h will move it left to right, translate it. The k will move it up or down, translation. So we're just translating here. So let's look what we have. We have minus 6. Now it's a minus 6, but since it needs to be x minus h, our h is 6, which means it's positive, which means it's going to translate 6 units to the right since that 6 is positive. If it ended up being x plus 6, it would actually be to the left because in order to get an x plus 6, since the form is x minus h, you have to have an x minus -6 to get a plus 6. It's counterintuitive there. K is pretty straightforward. It's a plus 2, which means we're going up 2. So let's get that. Now, don't take my word for it. Let's go ahead and graph this. And so we're going to graph two different things. We are going to graph just our standard parent function. So we need the f of x equals x squared. Let's get that. All right, that's standard. Now, what we want to do is we want to grab this g of x. Now, we need the f of x because it's going to transform that. Equals f x minus 6. You see how it moved to the right? Just doing the f minus 6 moved it over to the right, and then plus 2. So now it moved it over to the right and it moved it up 2. So my vertex is now 6 comma 2. So that -6 that's the one that is always a little bit confusing because that actually means it's a positive move. So that is our correct answer. Let's see how we did as a 2-point problem here. So it is possibly at partial credit. We only had, let me get this up here, 36% of our students get both of those correct. We had 27% get 1 point. So that means we had 37% of our students not get any points. And that's a little bit concerning. If you put half credit up there, you're looking at about 50% overall accuracy. So this was definitely on the harder side. We worked with transforming functions with parent-child functions, but typically there's some type of visual. We can obviously use the graph, but when it's just words, that definitely means it's a little bit on the harder side. It's tied for our 21st hardest on the test. For number 40, we are looking at recursive sequences. And so we need to look at the first 4 terms in the sequence. This is 8.12c. Now, we're not needing to come up with the actual equation, and that's sometimes difficult for students to remember. I know that sometimes I have a difficulty remembering that. They give us the formula. So we simply need to plug in numbers, okay? So let's look and see what it gives us. It gives us the formula, and it tells us the initial number, okay? So the A number 1 is 100, okay? So what does that mean? Well, that means that our first number needs to be 100. So our first number is 100. All 4 of these have a list with 100, so we don't have to worry about that. Now what we need to do is we need to plug in some numbers here. So if A number 1 equals 100, okay? So A number 2 equals, and I'm going to use this right here, 1.1 times A, and then A minus N minus 2. So A minus 2 minus 1. So what is A sub 2 minus 1? That's 1.1, and that's going to be A sub 1 because 2 minus 1 is 1. What is A sub 1? That's 100. So that equals 1.1 times 100. And so what that means is we're going to take 100, we're going to multiply it by 1.1, and so we're going to get 110. All right, so as of this, we're done. D is the only one that works, but let me show you how this continues to work. Now we're going to take A sub 3, and it's going to be 1.1, right? That's our rate. And we're going to do A sub N is 3 minus 1. So that's 1.1. 3 minus 1 is 2. So we're going to take 1.1 and we're going to multiply by A sub 2, which happens to be 110. So really all we're doing is we're multiplying 1.1 times the previous term. Once you have the initial term, you're just multiplying 1.1 times the previous term to get the new term. That's all we're doing. And so that's going to get us 121. And that's as far as we can go whole numbers. Then it gets into decimals. We get that 133.1, and we'll continue to get decimals there. But that's our answer. So they gave us the equation. Now, having that terminology that A sub n, A sub n minus 1 definitely needs a little bit of practice. And so we only had 29% of our students get this correct. We had 37%. And look what this is. It's simply adding 1.1. We're not multiplying by anything. We're simply adding 1.1. So this is simply one that's not necessarily intuitive. And unless you have some practice with this, yeah, I get the adding 1.1. This is our second hardest item on the test. It was the uh, definitely, definitely challenging. 29% accuracy. Number 41, we are looking at writing quadratic equations. This is 8.6b, and we need to write an equation for f in standard form, okay? And we are looking at a vertex we are looking at a point that it passes through. So this is our first clue that we're going to start dealing with vertex form. So if we look at our references here, we see vertex form, quadratic equation. It's right there. It's that f of x equals, and then all of that, and that's what we just looked at when we were transforming that parent-child function. F of x equals a x minus h squared plus k. Now I need to know what to do with the h and the k. Remember, that's going to be our vertex. So our h is going to be our x value of our vertex. K is going to be our y value of our vertex. So let's go ahead and plug that in. So f of x equals a x minus 5 squared, right? And then I've got a minus 17, or minus 1, excuse me. Plus negative 1, we'll go ahead and do that, minus 1. Well, I still have an x and an f of x and an a. Well, since it goes through this point, this means that we can actually take this as our x and our f of x because it must be true since it lies on that point. And so I'm going to substitute in my negative 17 for my f of x. I'm going to substitute in my 3 for my x. And now I've got everything except for the a. We need to know what the a is because we need to know if there's any vertical stretch or any compression. So we had to get rid of all the other variables. All right, so now we can simplify. So we're going to get negative 17 equals a. This ends up being negative 2 squared minus 1. So negative 17 equals negative 2 squared is 4. 4a minus 1. Let's go ahead and add 1 to both sides. So we're going to get negative 16 equals 4a. Now we can divide by 4. All right, so a equals negative 4. So now let's plug this back into the vertex form, to this one we had right here. I'm simply going to change out my a for my negative 4. So f of x equals, now it's negative 4, and then that's going to be x minus 5 because we know our vertex is at that 5 comma 1. Okay, so I don't have anything that looks like that. So let me go ahead and factor this out. If I can factor this out, this will get it to us in slope-intercept form. Not sure why they're calling it standard form because it's more slope-intercept form. So we need to go ahead and FOIL out or distribute out, right? So we're going to get that negative 4. This is going to be x minus 5, right? And I'm going to put brackets around this because I'm going to use that to FOIL because that binomial gets multiplied by itself. Negative 4, and then let me see what we're going to get. We're going to get x times x, x squared. Inner, outer, last, right? The inner would be negative 5x. The outer is going to be negative 5x. And then last is going to be a positive 25 minus 1. Now I need to distribute this negative 4 to all of these terms. I'm going to go ahead and combine this to negative 10x to make it simpler. And then I'm going to get what I need. Negative 4x. Negative 4 times negative 10 is going to be positive 40x. Then I've got negative 4 times positive 25. That's going to give me plus 100. Actually, it's going to be negative 100. So we'll go ahead, negative 100. And then I've got still have this little negative 1. So all we need to do is simply change that to minus 101. And here we go. We've got negative 4x squared plus 40x minus 101. That was a lot of algebraic reasoning, but we were able to get that. And this one actually did better than you might have thought. 56% of our students were able to get this correct. 24% were choosing this, and you notice they got everything else the same, except they made a sign error, right? And so they ended up with that positive 100 rather than negative 100, right? Like almost like I did right there. And then that kind of changed what you did with that minus 1 at the end. So they did all that work. They got really, really close. And then they got it incorrect. So this was right in the middle, literally 25th hardest slash easiest, depending on how you want to describe it, or tied for 25th hardest slash easiest. Next, number 42, we are looking at writing linear equations. This is A.2c, and we have a line. We need to find an equation. I mean, looks like it's pretty simple now. Look at our answers. It looks like they factored out a 3 or a 1/3. So we're going to need to do a little bit of work, but I do see a y-intercept of 3. So that looks like that's pretty easy. So it's going to be y equals mx plus 3 because my b equals 3. Let's look at our slope. And they go ahead and line out 2 points for us so we can use our slope, right? M equals change in y over change in x. Or we could just do rise over run. If you want to use the graph, that's fine. I'll calculate it here. So what is this point? This point right here looks like it's 9, 6, and I'll make that my x sub 1 and my y sub 1. And this point is going to be -6, +1. So that's going to be my x sub 2 and my y sub 2. All right, so let's plug that in. My y sub 2 is 1, minus y sub 1 is 6. X sub 2 is -6 minus, and then my x sub 1 is +9. That's going to end up being -5 over -15, which ends up being a positive 1/3. All right, positive 1/3. It is a shallow slope. It is moving up left to right. So if I plug that in for my m, I'm going to get y equals 1/3 x plus 3. Now, I don't see a 1/3 x plus 3. If I want to factor out something, I could factor out a 1/3. So this would be y equals, I'm going to factor out 1/3 because that's the easiest thing to factor since that's my coefficient right there. X plus, if I take a 1/3 out of my 3, 1/3 times what makes 3? Well, if I'm going to take that 3 out, that's going to end up being that 3 times that 1/3, right? Actually, we're dividing it by that 1/3 because I need to, if I times it by that 1/3, that would just get me to 1, but then that's not going to factor back out. I need to divide it by that 1/3, which means I'm going to multiply it by its reciprocal, which means it's going to end up being 9. Now, if you're not sure whether that's correct or not, let's just factor this out, right? Distribute. It's going to be 1/3 x plus 9/3. Okay, that gets me back to my 3. So not sure why they wanted to do that, just to raise the difficulty a little bit, but our answer is going to be C, and it didn't challenge too many students. We had 67% of our students get this correct, and so that was definitely on the easier side. This was tied for 6th easiest item on the test, so not too difficult. Next, for number 43, we are looking at exponential regression. And so this is A.9e. And we have a student dropping a ball. We have a table of values. You notice that as the number of bounces increases, right, the height decreases. So if we were to graph it, right, we would get something kind of like this probably. It kind of has a decreasing exponential curve there. And we need to look at our standard form. Y equals a times b to the x. That's how we get an exponential function. So there's two terms, all right? So this is going to be our initial term. So what happens when x equals 0? Well, when x equals 0, we're at 72, which means I can go ahead and get rid of these two because it's the wrong one. That's when x is 1. When x is 0, y equals 72, so it's going to be either A or C. Now, if you look at this, it's zero point 0.6 or zero point 0.4. So you can't just eyeball that. How do we get our rate? Well, this is our growth or decay rate. In this case, it looks like it's going to be a decay rate because it is decreasing, which means it's going to be less than 1, but both of those are less than 1. If one was greater than 1, we could eliminate 1 immediately. So how do we tell? Well, you can always find this rate by taking uh, each term and dividing it by the previous term. So for example, we can say 43.2 divided by 72. That's going to be the same as 25.9 divided by 43.2. I'm taking each term in the y and I am dividing it by its previous term. So 15.6 over 25.9, and then I've got 9.3 over 15.6. Any of those work. So we can get our calculator out. We can just start plugging some of those in. And let's see, 43.2. Let's make sure we've got 43.2 divided by 72. It looks like it's 0.6, but let's keep trying. 25.9 divided by 43.2. All right, you see how that turns into that 0.6 if you round, okay? 15.6 divided by 25.9, 0.6. If we round, it looks like we're just rounding to the nearest inch here. 9.3 divided by 15.6. There we go, 0.6 if you round. All right, so it is going to be that 0.6. And so that's going to equal 0.6. And so we're going to get our answer of A. Now, we had 61% of our students get this, so it's pretty straightforward. You can eliminate two answers immediately by just focusing in on that x of 0 equals a y of 72. So that's our A term, our initial, and then you just had to do a little bit of calculation. So 16, 15, and 7. This ended up being tied for our 14th easiest item on the test. Next, for number 44, we are looking at factoring trinomials. This is A.10e. And we have to find two expressions that are equivalent to what we have here already. And so we simply need to use our factoring skills. And so one thing we should notice is that look at all of our terms here. They can all be divided by 3. So let's go ahead and factor a 3 out of each of these. That's going to be our first term. And so if we take that 3 out, that's going to leave 6/3 or 2x squared plus 3/3 or 1, so that's just going to end up being x, minus 9/3 or minus 3. So that's going to be our first one that is the same, and we see that right here. And then our second job is let's go ahead and factor this as if it were a quadratic that we were trying to find the solutions for. And so we're going to leave this 3 out here, not do anything with it. We need two numbers. One of them has to be a 2, right? Because that's the only way to get to this coefficient here. But so and the only way I can do with this is I have a 1 times 3. So I need to put that 1 and that 3 somewhere. One needs to be positive, one needs to be negative, and it needs to end up with a positive x when you add them together. All right, so I want the 3 to be positive because that's more than 2. And I'm going to need that to be right here, right? And so look what happens if we do this. So we need this to be negative. So 2 x squared, that's the first, the inner 3x, outer minus 2x, and then last minus 3. So that gets us, that positive x that we're looking for. So that's going to be our second correct answer is these two binomials with the 3 on the outside. So we're simply factoring that 2-point problem. And so we actually did fantastic. 58% of our students got both points. And we had 31% get only 1 point. So if you put those together, you're looking at 74% accuracy. and only 11% got nothing. That's really good. So we should be definitely pleased with this one. This was the fifth easiest item on the test. Number 45, we're looking at solutions for systems of equations. This is A.3F. Now we do have a graph. If we want, we can graph it, but we don't really need to graph it. We need to find what is true. Infinitely many solutions. One solution. No solutions. Okay, so we could do a few different things here. You can graph it and you can find the point of intersection if there happens to be just one. You can use substitution. You can change one of these. I'm going to use elimination, but there's, like I said, there's more than one way to do it. What I want to do is I want to take this right here. I want to double this. Okay. And so I'm going to get 2x plus 2y equals negative 16. Okay. And then I'm going to get my 2x plus 2y equals 10. And then I'm just going to end up subtracting them, right? Subtracting this whole thing right here. Well, that's not going to work because look, that's going to get you 0 plus 0 equals, and then it's going to end up being negative 26. So 0 equals negative 26. All right, I am thinking that is incorrect, which means I'm thinking there are no solutions. Now, to verify this, let's go ahead and graph this. Now, we cannot graph it in standard form. We need to make each of these slope-intercept form. So this first one should be easy. We're just going to make this y equals negative x minus 8. On this one, we need to do a little bit of work. We need to make this 2y equals negative 2x plus 10, divide by 2. You need slope-intercept form for the Desmos calculator. So that's going to end up being y equals negative x plus 5. Well, I can already tell you that's going to be a problem. Take a look. We have identical slopes. Identical slopes mean they are parallel, which means they never touch. They just have different y-intercepts. But we'll go ahead and put this in here so we can verify. So we want to put both of those in here. So y equals negative x minus 8. So that's going to push it down. And then I've got y equals negative x plus 5. That's way high. And they're parallel, never touch, which means there's no solution. All right, so that is going to be our answer. We've got D. We've got no answer, no solution. And it's because they're parallel lines, and that there's going to be no solution when you have parallel lines. And so this was 46% of our students that got this. 21% figure there's got to be a solution somewhere, but take a look at this. 21, 17, 16, that means this is quite a bit of guessing right here, because those three are very, very similar. So this ended up being hard. I think the fact that it was in standard form, we might have tried to eyeball it, made it difficult. So, or what we might have done is this probably works for one of them, and it probably works for the other. And if it works with one, they might have checked it with both. In order to be a solution, it has to work with both of our equations, not simply just one. So this ended up being our 15th most challenging item on the test. You can't just plug these numbers in because it has to work for both. For number 46, we are looking at linear equations and the distributive property. This is A.5a. We need to find the value of v that makes these equations true, and sometimes you can just plug these answers in and see which one works, but look at all those fractions. We want to play with that. Let's solve for v. So we have these terms, and what's really bothering us right now is the fact that they're both fractions and that they don't even have the same denominator. So I want to multiply both sides by something to get those fractions out of there. And if I multiply by 5, then that's only going to work on the left side. It's not going to help me on the right side. If I multiply by 2, it's going to help me on the right side, not the left. But 5 times 2 makes 10. So if I multiply both of these by 10, It's going to end up being a little bit bigger than I wanted, but it's going to get rid of both fractions at the same time, right? So I can simplify here. 10 over 5 makes 2, so that's just going to leave me a 2 up there. 10 over 2 makes 5. So that's just going to leave me a 5. So it's going to end up being 2 times the quantity v minus 6, 5 times the quantity v plus 10. Now let's distribute on both sides. We got to make sure we do the right thing with the 2 and the 5. So that's going to be 2v minus 12 equals 5v plus 50. Now, let's just solve for v. I'm going to subtract 2v from both sides. It's going to give me 3v and 50. Let's subtract 50 from both sides. Now we get this really janky 3v equals negative 62. Then divide both sides by 3, and this is what you're going to get. V equals negative 62 thirds. So they definitely wanted us to use the distributive property and not necessarily just to plug our numbers in. So only 42% of our students got this correct. 30% chose this, and they only distributed the first term. If you want to get this negative 16 thirds, what you end up getting is you end up getting 2v minus 6. So they distributed the 2 to the v, but not to the 6. And then the 5v plus 10. They distributed the 5 to the v, but not the 5 to the 10. If you work that out, you're going to end up getting negative 16 thirds. So we still need a little bit of extra work with the distributive property. And some students might have been a little bit confused as to what to do. How do you get rid of those denominators that don't have the same number? And multiplying by the product of those two denominators, that ended up being our solution. This was tied for the 11th hardest item on the test. Number 47, we are looking at writing exponential functions. This is A.9c. Now, we do not have the standard form of exponential functions in our materials for our reference materials, so we just need to know that it's going to be y equals a times b to the x. That's our standard form. This is going to be our initial value, our starting point, our y-intercept, right? In this case, it's going to be the amount of money that we start with, our principal, okay? So the bank customer opened a money market account with, here we go. That's how much money we started with. Our principal, sometimes it's a deposit. There's a lot of different things this could be, but what are we starting with? We're starting with 2,500 bucks. Now, the B term is your rate. So decay rate or growth rate. Since it's a bank account, we're wanting to increase money. Okay, we're going to increase it by 0.5%. Now, we're not just going to put a 0.5 right there. That's not what we're going to do because this is a percent. So this is 0.5 hundredths. Okay, so if we put this on a place value, right, we're going to end up with our ones, our tenths, our hundredths, and this is 0.5 hundredths. So that ends up being thousandths, 5 thousandths. Now, that's how much it's increasing. In order to put that as a rate, we need 1 plus that rate. So 1 plus 0.005. So that's going to get us 1.005. We need that 1 because if not, it's going to shrink drastically. That 1 keeps the initial value, and then anything above 1 is what makes it grow. And then we have our x. Now, in this case, we're changing the x to the t for years. So this is going to be our t. And then our a is going to be our y value. But other than that, we have, look at b and d. They look very, very similar. You notice this is not an exponent that's tricky. That's just multiplying. That is an exponent. So we need b. But I do see where D could kind of throw some students off. We only had 41% of our students choose B correctly. 33% made the mistake. They saw this 0.5. They saw that right there. It's not ever simple as that. The rate is the 1 plus your growth or decay rate, not just the rate itself. And the 0.5% is not 0.50. It's 0.005 because percents are always out of 100. So a lot of different things to kind of mess us up. This ended up being tied for our eighth most difficult item on the test. Definitely a challenge. And this was A.9C, excuse me, A.9C. Number 48, we're looking at A.11B, laws of exponents. And we can actually get our reference materials out for this one because we have these exponents here, right? We have the power of the power. We've got quotient of powers. We have negative. We have all of that. So let's go ahead and just open this up. Keep it right there. All right. So let's deal with this negative exponent first. Okay. So what happens when we have a negative exponent? Well, that means that we're going to take it down underneath. We're gonna invert it. So this is going to end up being 1 over 6y cubed, that quantity squared. That negative 2 brings everything down into our denominator. And then that y is still sitting there. Okay? So now we need the power of a power. Got to do something with this. I need to square all of this. So this is going to equal 6 squared, so that's 36. And then y cubed squared, that ends up being just 3 times 2. Y to the 6th, and then I've still got that y sitting there. This lonely y has been there the entire time. So now I've got the product of powers. I've got y to the 6 times y. This ends up being y to the 1. You end up adding them together, 6 plus 1. 1 over 36 y to the 7. So we needed to use a negative exponent, that power of a power, and the product of powers to get our answer of 1 over 36 y to the 7th. Now, probably not surprised that almost as many students chose B. Very, very close. And after they did all this, you know what they probably forgot? They forgot that Y. That poor little Y that they just kind of drug along for the journey got dropped at the very end. And so this definitely was a challenge for some of our students. This was the third hardest item on the test. And so when we're practicing this, we need to make sure that we're applying, as you saw, we had negative exponent, we have power of power, we have product of powers. Multiple properties within that same problem is going to be the best practice for our students. Number 49, we are interpreting exponential functions, and this is A.9b. And as you see, we have drop downs. So we have 2 points possible on this. And once again, we're going back to our initial equation, which they don't have on our reference materials. Y equals A times B to the X, right? So this is going to be our initial, our starting, Y-intercept, whatever you want to call it. If we're dealing with money, we're dealing with a principal or a deposit. There's a lot of things that would work here, but we're looking for our starting position in this particular term. And then B always gets us our rate, either a growth rate or a decay rate, depending on what it does, right? It's 1 plus that R, okay? So here's the exponential function. Town population can be modeled by this exponential function. All right, 26,080. That is in the A term. So what does that mean? Well, since that's the initial starting point at 2010, our initial population is that 2680. That's our starting position. So that's our first point right there, since it's at 2010. So they're telling us this is at the beginning when we want it. And then, was the population increasing or decreasing? Well, how do I get to this 0.85? Well, if it's less than 1, it's decreasing. Okay, so this is less than 1. And so 1 plus R is going to get me my rate of 0.85, right? And so if I subtract 1 from both sides to isolate that r is going to equal negative 0.15. So it's got a 15% decrease. 0.15 is below 1. That's how we're getting that 0.85. So just because it's a positive, don't let that bother you because it has to be positive for it to be exponential. But you're looking at whether or not it's greater than 1. So we are decreasing at a rate of 15%, not 85%, 15%. And that's how we're getting that 0.85. And so this was a 2-point problem. Only 25% of our students got that correct, both points. We had 36% of our students get 1 point, so you put those together, you're looking at 45% overall mastery. 39% got 0 points. This was definitely harder because you're having to interpret and to make sense. And unless you spent a lot of time practicing it, this is going to be the hardest job. We can grab that A term right there. It's that B term, knowing it's a 1 plus R, and then if it's a decrease, all of that. That's just quite a bit of steps, and we need a lot of practice with that. This ended up being, like I said, 14th hardest item on the test. Finally, number 50 is our final problem. This is A.3b. We're looking at rate of change. And so we have the graph of a student's distance from home, and we're looking at what is the rate of change of the student's distance from home. Look at this, distance from home in miles, y, with respect to over time in minutes, x, y over x. So we're looking for our change in y over change in x. We're looking for our slope, right? We're looking for rate of change. There's a lot of different ways that we can look at this. All right, so, well, we're definitely not increasing. We are decreasing. And let's just find some points here. I see that right there, and I see this right here. So what does it look like we're doing? Well, it's going to be 1, 2, 3, rise. It's going to be -3 over run. 1, 2, 3, 4. All right, looks like it goes 3 miles closer every 4 minutes. And so it's going to be that -3/4. And if we want, it would work as for this as well. 1, 2, 3 over 1, 2, 3, 4. And it's that first move down that gets us that negative. So our answer there is A, decreasing at 3/4 miles per minute. We had 64%. So we ended on a high note. This was definitely a little bit on the easier side. As you can see, if we just flip it, if we think the rate of change is x over y, you're going to get the 4/3. So 20% of our students chose that. And this ended up being tied for our 11th easiest item on the test.